Hey everyone, how are we doing today? Welcome to the stream. Let's start the timer while I'm doing some final setup. Let's see. How is everyone today? So I was trying to go live on X, and I was trying to find some um, like proper article. Couldn't find it instantly, and then I realized that you can only stream on X if you have premium. And so, not yet. Hey EF, hey Tupsin, how are you guys? Can you folks hear me okay? Hey, say Yuday, how are you? Thanks for joining. Okay, I think I'm actually good to go. Let me bring up my screen. I actually think, I think I saw an announcement today about some session with, I think, Kelsey Hightower. And I think it's going to be about Massdriver, which is another infrastructure as code solution. I'm going to find it right now. And if that's the case, I think it's going to be 2 hours from now. If that's the case, we might spend an extra hour doing like a reaction thing, just because I am quite familiar with infrastructure as code. I actually saw a demo of Massdriver before but I haven't tried it. So like I don't even know if they're going to talk about Massdriver or something else. But because it's Kelsey and because it's infrastructure as code, I think it would be worth doing that. So let me find the link for that, because yeah, I think this could be interesting. Okay, let me switch my screen. Okay. Yeah, let's see. I also need to find a link. Okay, I don't have any bookmarks. Maybe folks, you can help me find what I'm looking for. So maybe how do I do this? And meanwhile, let me add an announcement. How do we find this? Yeah, maybe through Massdriver. Yeah, join Kelsey. So Kelsey, by the way, is a very well-known figure in IT world. He's been working at Google for quite a while before he left. Why GitOps isn't an answer? Yeah, I'm interested in this. Let me check when it is. I think it's in 1.5 hours. So yeah, chat. Are we interested in like watching this together and having like a reaction or something to this? After we finish with Pulumi today. Awesome. Yeah, okay. So then let's not waste time. Let's go ahead and do stuff so then we can have a sense of accomplishment, do some progress, and then we can switch to like chilling and doing some reaction content. I actually have never done reaction content in my life before, so let's see how that goes. All right, let me kill this window. Let's go do useful stuff. All right, so I need to bring my what? Code editor. Oh, I am now on cursor. I forgot. I am now writing code with Gen AI tool. But I don't really like I like how seamless the experience is in cursor, and yet like sometimes Gen AI code auto completion is just bad. Like you're just trying things out all the time until you hit something that works and doesn't feel good. Okay, so let me bring up my machine. Out of memory. So I guess VS Code or Cursor has a memory leak then, because I think I didn't touch this machine for like 3 days. And yeah, maybe let's reload this just to be safe. And while it's reloading, I can do like an intro. All right. Hey everyone, this is Dmitry. Welcome to my stream. Today we will continue playing around with Pulumi. I will focus today on the multi-environment deployments, like dev, stage, prod, maybe multi-region as well, but we'll see. I also had the chance to reach out to Pulumi team and got some answers. So we might refactor some code according to their recommendations. I'm going to cover this in a second. Yeah. And then depending on my mood, we might add some new features to like our VPC construct. So this is what we are going to do for the next 100 minutes, because at 7 p.m. Central European time, or like 1.5 hours from now, there will be some webinar or sorts or live stream with Kelsey Hightower and Massdriver team. I suspect, I don't know if it's going to be about their product, the Massdriver product, or it will be in general Kelsey thoughts about IAC. But I like Kelsey. IAC is an interesting space for me where I think I'm pretty good at. So we'll do some live commentary and watch it together. All right. Let's get started then. Okay, so does this work now? Yeah, it does seem like it's working. I found a doc page in Pulumi that is describing this file, and it actually like there is something to it that like it's bad that I missed it last time, but it's good that I found that doc. So we are going to go through that doc because it will prompt us some refactoring. Like I actually misunderstood a little bit of this. And we will see how that is working out. At some point, so we have been building so far the AWS VPC, well-architected VPC. According to like my experiences with like building networking components on AWS. So I will try to make it like as flexible as possible. And at some point in the future, I think we will publish it somewhere. But that's like yet another story, I would say, of like how do you actually publish and reuse components within Pulumi? Because that's the reason. There are several angles to that. I want to give a shout out to Josh from Pulumi, as well as to, and I'm sorry, I forgot the name. So to Richard and Josh from Pulumi, we had some discussions regarding some of the like problems or challenges I've been seeing. So they helped me clarify a couple of things. So I will cover this in a second, but let's make sure we log into our accounts first and all of this kind of admin before that. Oops. Okay, so yeah, can I get where I need to get? So I need to get to my AWS account. let's log in here. And by the way, if you are not have joined the Discord, make sure you join the Discord. It should be, I like, if this is on YouTube, under any of my live streams, there should be a link. And if you're on Twitch, it should be also in the below, because that's how you can get notified when I stream. I'm trying to stream quite frequently. It will probably always start at the same time. I plan to stream tomorrow as well. Maybe I even start a little bit earlier tomorrow. We'll see. Yeah. All right, so we are good here. Let's see if our Pulumi account here is good. Yeah, we are. Did I forget to delete? I think I forgot to delete all of the stuff. The good thing is I don't have to pay for anything from here. So that's a good side. The bad side is I forgot about it, which means the next time I deploy something for which I have to pay, I will also forget, probably. Okay. We have this. We have our AWS account. I think the last time we created 2 VPC from a single template. I don't know what this is. Let's see. Is it? Oh no, there are no resources. I guess I destroyed this one, but I didn't destroy the another one. Okay, so let me bring up the code. Okay, so very quick recap of where we are. One sec, I will check here. I'll check here the stream settings. No, all looks good. Okay. Okay. So what we have is we have a Pulumi program that deploys a VPC. Now, this program is written in Python, and it has what the Pulumi calls component resource. So component resource, you can think about it as a collection of resources. In other infrastructure as code solutions like Terraform, it will be Terraform module. In CDK, it's going to be a construct, right? So it's basically a collection of resources. So in this case, I have VPC. I have CIDR blocks. I have subnets. I have internet gateway, virtual gateway, route tables. And we implemented all of this, which is pretty awesome. So you build a logic for it, you create all of this stuff, and then another concept is stack, right? So stack, this would be an instance of your reusable infrastructure, right? So in this case, we started first with dev, and what I did is I had here the appropriate folder structure, applications. I have application called dbot in EU Central 1. It has dev and prod, and I have a configuration for it. So there was a configuration in specific formats that I defined, and I wrote a component resource that takes this configuration and creates appropriate resources. So what you can do is you can have multiple of those, and this will be like multiple stacks. So that's like the main building block for the like multi-environment deployment in Pulumi. So there was one thing that Pulumi folks clarified for me. So that said, I don't think I fully, I guess, agree with the user experience, if that makes sense. So there is this function called register outputs, and you can like say like kind of like what is the output value for this component. I thought that once you define it, then you can reference these values from like the outside the stack. Like where is this? In the main PY, I thought I could say, okay, I created this custom VPC over here, and then I say you can say VPC dot whatever I defined in that register outputs things, and they told me you cannot do it. You actually have to reference underlying resource like this. So I am a little bit, I guess, conflicted by it. Like, I don't think this is good because now you kind of expose like a structure of internal module, if that makes sense. I want to encapsulate outputs in a way that I can like reference them. So my understanding, and I haven't tried it, so we will try it today. What we can do is like typical Python stuff where you create a property or something that will reference in something else, and then you can access it this way. So that's something I want to test out. I don't know if this is going to work. But yeah, we'll see. So because this I don't like. Okay, so this was the first part. So apparently this register outputs is not for this functionality, so no wonder it didn't work. Okay, so second part, there is apparently, like you see how I created this folder structure like this, right? But apparently this Pulumi file, pulumi.stackname, is the file where you can actually provide all of the configuration for that stack. It has a little bit of magic to it. So that's something I want to explore fully. So it does seem like I need to take this file and like merge it with this kind of configuration. So that's what we'll try to do. Yeah, we'll walk together through the documentation piece for this and try to make it work. Okay, so this is this part. So second part, so second part is, okay, what if I want to create this kind of template, like these VPC resources, and then I want to publish it somewhere, right? So like in Terraform, you can go to any GitHub repo and publish the module. You can publish the module directly to the HashiCorp registry or Terraform registry, whatever the name is. So here, there are multiple ways to do it. So option number one is this. This is a Python code, right? So this will only work if the user uses Python, Pulumi Python as well. So in that case, we move it to a separate repo and we publish it on PyAPI. Okay, so that's like one way. Now the good ways, like, Python is relatively easy, so, and I think I'm pretty good at Python, so, like, this is awesome for me. Now, you as a consumer of this module, you can only benefit from my work here is you only if you also do Python, right? So this is not cross-language, even though Pulumi is cross-language. So that's option number one. So then option number two is it is actually possible to create language independent like components, I think they are also called. You have to write them in Go, and then they can compile to different languages. So then this way, anyone can use it. Now, so my thinking process would be on this. Like for now, we are kind of like learning, and I will probably at some point, once I think it's good, I will publish this somewhere. But I don't think I will start, like I will try to make it like as applicable to everyone as possible. Because like, I don't know Go. In Python, I am very productive. I can do like pretty much anything in Python. So I will publish it in Python. I hope I will get some feedback. And only if there will be like business need, like there will be enough people asking for, okay, I like this, but I want to use TypeScript or whatever. Can it be rewritten in Go? Only then, like I would think about rewriting this in Go. Now there is some other thing here that is pretty interesting. Now I like to use Python tools, special Python libraries that I like to use. One of the main libraries that like almost the cornerstone of writing good Python for me is called Pydantic. So it is here as a dependency. Pydantic is over here. And what I do with this, I like to define kind of like the schemas like here. In this case, I define a schema for my input config. I use it in almost all of my Python projects. It's very powerful. It's very easy to use. Like, it's just awesome. If I were to try to make this multi-language model in Go, like I cannot use the tooling that I like as well, right? So that said, Pulumi actually has, let me find it. Pulumi has its own kind of like schema language, if that makes sense. Let's see if I can show this. So this is seems it's the repo to create this kind of Go stuff. Where is this? Is it here? Guess it's here, right? Random resource Go. Okay, I'm not 100% sure, like I haven't written Go, so like It's hard for me to navigate. I think something like this. This is like their schema thingy. I saw they have something like this in Python. Pulumi types. Maybe Pulumi input Python. Yeah. Yeah, something like this. They had like Pulumi.int, I think, and Pulumi.strs, like something like this, where like kind of like their own schema language. So yeah, but I like to use Pydantic, but that's only possible if my component on its own is in Python. All right, so the key here is this. I would say this is very, very important documentation page, which I missed. So we'll be going through it together and we'll try to modify our project together. So here's the thing. So you can create the pulumi.stackname.yaml file. And it contains a configuration that is specific for that stack. And again, remember, stack is like a one instance of your deployment. So if you have a VPC module, the stack would be an instance of a VPC. So you can create another stack and it would be another instance of VPC. So as you can imagine, this is a very important thing. So in Terraform, this would be like root module kind of thing. So here is a little bit different abstraction. Now, the one way to interact with your config, there are namespaces here. So there are namespaces like this, aws.region. So, and there are like some other defined things. Now, this is something that I haven't, I think, found, but maybe we can find it. I suspect Pulumi Pulumi AWS provider. I hope it's somewhere defined. So it will have, no, that's not it. Okay, here. So we can do it based on environmental variables. But in this case, like I have login credentials to SSO, but then I should be able to log in to like any other account through my credentials. Then you specify, for example, you need to specify a region. You can do it via environmental variable, but you can also set it in that config file like we are doing here, right? Okay, this is not relevant. This is how you set up AWS stuff. Here, you can also set up aws.profile, which is awesome, right? So with aws.profile, we can set different accounts, and like my stack 1 would go to using this profile to this account. Stack 2 will go to this profile to this account. We might even try to create a separate account and like test that out. So you specify, like, you basically have to find this. Like, I wish they had like more formal. I really wish they had. Oh, it's actually over here, right? So inside of the module, uh, there are configuration options, and you can see it like you need to namespace them with whatever the documentation says. So those are the things that we can do. So we can set a region, assume a role. I suspect there should be a profile here. Profile. So this way, different stacks can go to like different accounts, for example, and use different role. So this is very useful. So this is namespace configuration. There are Pulumi packages. Isn't the way how to share created packages? You can generate packages for all supported languages. Yeah, but you can do it, but your code needs to be written in very specific place or in very specific way. And I think like this part I don't fully understand. Pulumi shared package. My understanding is that it can only be written in Go so that it can be converted to any other language. You cannot do it in Python. They have here example, but I don't think this is that. This is just Pulumi. Maybe here. Pulumi provider packages. Yeah, it does seem like the instruction here is in Go. Right, so you need to write this in Go. I don't know if you can do it in TypeScript, but yeah, Python doesn't seem to be a supported way to do it. Okay, so let's go back here. Yeah. All right, so this is, we covered this namespace configuration. So this is, in this case, it will be configuration that is specific to the provider. In this case, AWS, Pulumi AWS provider, right? So this is exactly what I needed if I want to deploy one stack in one account and another stack in different account. And maybe if we'll have some time, I will try to make that work. So then they have like a no namespace configuration. Not 100% sure about like how to use that. Oh, excuse me. What else? Config flag. Okay, this is when you create a new project. Like, I don't think I need this. This will just write it to the pulumi.dev or whatever is the stack name file. Whatever. Okay, so then this one is important. So this is now, okay, you put this in that YAML file. How do you interact with it if you need to like parse it, kind of like modify it? What do you do with it? So this is what you do. You can get this configuration and then like do this kind of stuff. So you can see they do have like a kind of like this function based approach here. Like you can mark that something must be required parameter. Maybe like I do want to see like what kind of errors you get. Um, let's try this out. Okay, up is fine. So this should get it from the like I guess like root level or something. Let's see how this works. Because in this file I don't have it specified, but it actually like highlights this for me. One second, folks. I managed to spill some Coke here. Okay. Pulumi packages are multi-language. You can write your package once in Go, Python, or TypeScript, JavaScript, and then make it available to all Pulumi users, even if they use another language. That's. Could you help me find like a how to do that? Because that's like not my understanding. Okay. Let's get this thing running. Uh, some error. Okay, so this is an error that I don't have a config, right? So, okay, so this is actually pretty nice, right? So like, it's not horrible. Um, which I guess is a compliment. Not horrible. My only kind of I'd say gripe is it like maybe that's not an interface that I really like. In Python, I really like Pydantic, which like does all of the config parsing. But we'll get to it. Maybe we can marry these two together, and we'll see how that's working out for us. Let's go ahead and fix this first. So app dbot, and then let's just print this on the screen. I do need to I need to log in. Okay. By the way, folks, have you seen that AWS now supports multi-session in the browser without extension? Multi-session. Look at this announcement from yesterday. I think here. So you can sign into multiple accounts in multiple tabs. I'm glad it's finally here. Okay. So I think let's do Pulumi up again. Region short. Oh, it did auto completion for me. God damn it. God damn it. Yeah, let's run this. Oh, by the way, so something else, but I think we figured it out last time. You do want to add in component resources, you want to add this kind of options to make sure you have like a proper relationship. Okay, so we are done. So we can go to our VPCs and find our prod VPC. Pretty nice, pretty nice. Okay, so let's now try to kind of feed this in the Pulumi configuration framework. Okay, there was one, I think there was one key there. So I didn't go through this whole documentation page fully, only like part of it. So let's try to do it. All right, so this is understandable. So we can even extract those other pieces there. Basically like just gets config dot something. If you're writing code that will be imported into a broader project, such as your own library of Pulumi components, you should instead pass your library name to the config constructor. You should instead pass your library's name to the config constructor to limit the scope of the query to values prefixed with the name of your library. Okay, so what they're saying here is, since we are going to like potentially publish this somewhere, right? You would want to hide the configuration under some namespace from like this top level. Yeah, so like you limit it to this namespace and then you put it there. So something is interesting though, like, yeah, I don't know if I agree. Do I agree? Let me think. Do I agree with this or not? So let's say I'm the one who wrote the component and you now want to use it. I should probably not like from one perspective, I think I shouldn't enforce the name. How do I do this? Like from one perspective, like I should only require you to give me a config in specific format. But I shouldn't necessarily enforce you to use a specific like a namespace. Like because I can kind of like name them randomly. Is this like even a good idea? Okay, we'll try to explore this because you can see that they're trying to get configuration here inside of the component itself. Okay. I'll try to think about this in a second. I think we might have a way to like solve this. Okay, structured configuration. Yeah, like you can do it via CLI like this. I don't think this is I don't think this like interacting with this in the CLI is very helpful. Like you can just write it directly to YAML file or something. Let's see our chat. What's going on in chat? Hi, quick summary on what am I doing. Hi, Skeleto. What I'm doing is I am trying to become quite advanced with Pulumi, which is infrastructure as code solution to deploy cloud infrastructure. Been using Terraform for a really long time. I'm very good at Terraform, and I don't like I'm having some issues with Terraform, so I do think that Pulumi is a better tool. So I want to make sure that I am proficient with it. I can build whatever I want with it, and that the tool doesn't get in the way. Right now, I am exploring how I can do multiple deployments with a single template properly in a way that the tool prescribes. Traxio first steps into the use of Pulumi. Yeah, I would say I don't think it's already first steps. I think I am getting a hang of it. Maybe like I'm not like fully familiar with all of the constructs, but I think I'm like more or less comfortable with what's doing. So like I think at this point, like if I were to build cloud infra for some company, I'm at the point where like I can use it more or less no issues. Okay. Let's go back. All right, so I think it's scrolling me to some like random places. I don't get it. Okay, this stuff, whatever. For structured config, true and false data are persisted as Boolean values. A data config can be accessed in your Pulumi program using require object data. What does it mean? Structure config. Yeah, I'm not sure I'm getting like what they're trying to do here. Is it just because this has nested values or something? Okay. Project level configuration. Okay, so you might want to set some configuration for all stacks. Yeah, by the way, this is actually... Is this useful? Setting project level configuration. Yeah, so they give an example here, AWS region. I actually don't think this belongs in the project level configuration, even if you're doing single region, because like technically you can do multi-region. So is there a better example here for like project level configuration? Yeah, I think there could be. So what I'm thinking about, but I don't think this would be applicable to the module that I would publish publicly. But this is something that might be useful for like the code that I write internally. So imagine I built a module internally, and then in the project level configuration, I can specify, okay, all of my VPCs have VPC flow logs, and I'm doing this configuration there, and it will go to CloudWatch. So like I'm specifying this for all of the stacks there. So I think maybe this could be a better example for this, because I honestly don't think AWS region is a good project level configuration. Could you give me an example where you're stuck with Terraform, and are you relying on Pulumi to solve it? Yeah, I can actually give because I prepared it last time. There is Excalibur here. Now, this is a very particular example that cannot be expressed in Terraform. But in general, like I like to build abstractions which are very easy for the users, for the consumers to like use. So I like my inputs defined in very specific way. So it will be like list of nested objects and stuff. Because like, you know, I only need XYZ from my consumer to give me to build a like reusable infrastructure that makes sense. And so what this boils down to is my inputs are very simple and like in a way that any kind of human can process and provide. But then the module internals are hard because expressing simple inputs in Terraform specifically is actually quite complex. So I can, I think we even have it here because we built it. So let's take a look at this example of a VPC. So in this VPC, I have two CIDRs with two different CIDRs belonging to a single VPC. Now in subnets, like I don't want to do manual breakdown of subnets because technically a computer can do it for me. I can say from this CIDR block, give me /24/24, then /27, maybe like some other size. So this is dynamic allocation from the CIDR. I did this in Terraform as well, and I hated every single second of it because like you can like there are only really like function how it's called, it's almost like functional programming there in Terraform when like okay you have a let's say a list of something, you can apply a for loop and convert it to some other list, but you cannot like really have variables inside of a for loop or something to like make it easier. So like all of this is like, okay, I have a list of array of things. I transform it to another array. I transform it to another array. And this kind of implementation in Terraform was really, really hard uh, to implement. Now, apparently when we started to building this in Pulumi, we actually reached a case which cannot be expressed in Terraform whatsoever. And I remembered I had the problems with exactly this after this kind of implementation. So here is an example. You have your VPC and you actually add 2 additional CIDRs. Maybe your VPC grew and like you didn't envision this growth. So I have here primary VPC CIDR. I have here 2 secondaries. So you create a subnet first from like your primary CIDR. Cool. So then you decided to extend your VPC with VPC CIDR association. So you added a new CIDR. So then you create a subnet. And the subnet in AWS constructs, they actually don't depend on this secondary CIDR association. The only thing you do is you say, okay, this subnet belongs to VPC. However, if you try to put a block that is not available, then it will fail, right? So what this means is that there is implicit dependency of this subnet to this VPC CIDR association. What this also means is that you cannot delete this subnet before, actually vice versa, you cannot delete this block because the subnet implicitly is dependent on this VPC CIDR association. Now, if you created the subnets using for each, because that's how you would build something like this, like you actually do need to do for each here. This depends on has a lot of shortcomings. So like you would have something like AWS, I think subnet, like this or whatever. You have for each some kind of for loop. Like you do VPC ID is like whatever, AWS VPC this ID, blah, blah, blah. And then in this case, you would have to say depends on, and you say AWS VPC, I think CIDR association, like this, something like this. So there is a big problem here with this depends on. So first, this depends on, you can only provide here a group of resources. You cannot say this or this CIDR, right? So it will be applied to both. So you cannot be granular. And then you also have this problem from another perspective. You have here for each statement. So some subnets here are actually don't depend on this block. So this middle subnet doesn't depend on VPC CIDR association. This subnet depends on this right VPC CIDR association. This left one depends on this one. So you actually cannot express this dependency whatsoever in Terraform correctly if you are using for each and depends on. The consequence of this is if you wanted to extend a CIDRs here, the only way to do this is you need to do a targeted plan and apply. So you would need to run terraform plan target, and then you only do plan and apply on this top block first. So like you extend this VPC first, and only then you run it on this level. And if you don't, like, it will just not work, it will break. Now, granted, like this is very complex scenario. Like I don't think, like I'm not sure if anyone has ever done something like this. And so like maybe it's like not a good example either. But like I stumbled upon it when I was building the same thing in Pulumi, and it was really simple to do. Like, because for every single subnet, I could say, okay, this subnet depends on this block, and this subnet depends on this block, right? So I'd say like more down to earth would be like in general expressing complex architecture dependencies is like just hard, and doing it in programming language is easy, well, relatively easy. And then you have full power of your programming language of like you have your favorite libraries, you have your debugger, you have your ID autocompletion. So all this is awesome. You're looking for something like infrastructures, and Aptera is purely declarative and fully predictive. I don't know what infrastructures app means. I think I know what a good abstraction is. And building good abstractions in Terraform is not good. That's my take on it. Okay. So where did we stop here? Right, so this require object data, I'm not sure I fully get it, but I don't think it's that important. Project level configuration. Yeah, we talked about this. I don't think region is a good project level stuff. But again, whatever. Project and stack configuration scope. Stack level configuration using the same key supersedes for that key. Yeah, okay, so this is like just override. That's fine. Strongly typed. Yeah, okay. This is something that I saw, that like in the main file, in this like Pulumi file, you can like make types for the configuration. So this is kind of like variable CF. I think this is something similar. I don't know what I think about it. It's hard for me to say if this is good or not. I just like Pydantic. Pydantic will parse everything for me. Provider configuration, provider key value, sure, whatever. Okay, you can disable. There are some tags that will be in the Pulumi console. Whatever, and you can use Pulumi EC. So EC is another product. Maybe we'll explore it in like a couple of streams, but for now, I'm not really interested in that. Okay, so let's try to make this work. So basically, my understanding. Are you sure you want to move Pulumi? Huh. So, will this even work? Does it have to be... Huh. So something that bothers me here, like I want hierarchy, right? So like I want this hierarchy. Like I like it. Now, if I put this file there, this will not work. I think. Well, it can't work. Or it can work. No, it cannot work. Yeah, it cannot work because We don't know where our configuration file is stored, even though, oh, it's over here actually. We just like don't know where it is. Now, should I? Is there a way for me? Huh. I don't see here a way to specify the path to the configuration file. Like, there is this assumption that it is in the same folder where you run it. Maybe help. Maybe you can provide it. I suspect you might be able to provide it. Please pass the file. Oh no. Config path. Use configuration values in specified file rather than detecting the file name -c. Yeah, okay. Right, so this is fine. This is like what I need. So I can say C applications dbot EUC1 yikes. Yeah. Okay. Yeah. What? Oh, okay. I didn't provide pro. Question mark? Is it what? Minus config? Is this incorrect? Applications, dbot, EUC1, prod, Pulumi, dbot, EUC1, prod YAML. Please work. No, it doesn't work. Huh. You know what? Just to be safe, I will do relative pass. Create configuration variable. Maybe. Come on. Is there some debug mod? Debugging? Pulumi extension. Show automatic. Open your program file in code and set a breakpoint. Run and debug. Pulumi CLI output in the debug console. Yeah, okay. And we'll try this. I don't know. Pulumi. What are they saying? Open your program file and code, set a breakpoint. Run and debug icon. To show all automatic debug configuration, Pulumi. Oops. Pulumi up. Use config file instead of to specify the file. Did I misspell the argument? Oh, I mean, yeah, in this debug. Yeah, you might be right. Okay, how do I kill this debug console? Quit. See, exit. Um, system exit. I don't know how to kill this debugger. Not exit, not quit. No. No. Okay, I would just do it like this. But I think it's still there. It's still there. Okay, I don't know how to kill it in the cursor. Whatever. Oh, okay, I see. Shift F5. Finally. Okay, so what you're saying... Let's get the terminal back. That it's not minus minus config, it's minus minus config file. Let's see. Yeah, I think you're right. Config to use. Yeah, I thought it's kind of like all the same thing, but yeah, I think you're right. I do need to do a minus minus config file. Yeah, thank you so much, Tush. Let's try this out. I think you are correct. So this would be... Let's do Pulumi app config file is equal to... We will do relative path. Please work, please work, please work. Let's go. Yeah, you are right. Perfect. Thank you so much for help. Chat, you're great. Okay. Right, so we are getting somewhere. So now we have this Pulumi configuration file. I think this is good. So I'm thinking that so I suspect yeah, so like I technically I don't really want to force a user to say, okay, the only way you can use this if you name a key like this. I think this would be counterintuitive. But what I can do is I can set as some kind of namespace. Probably I need to like prepend it with my name because with my username because like it would be like under like some kind of my module if I could publish it. I guess like this. TM-Figo AWS VPC. So then I need I think this is what I need. TM-Figo AWS VPC. So then an extra thing that I could do is by default, you give me VPC config. Like it just needs to be structured in a specific way. You can give me any kind of like it can be in arbitrary hierarchy in your place. You just need to conform to my expectations. But what else I can do is if you I think this doesn't work correctly in cursor. Like, okay, yeah, this is fine. So I can say, I can define a new class method, and I don't know if Pulumi will like it, but we can try this out. Where I can say dev class from default config or something like this. Huh. Maybe from config. So I would accept a from config data and then data, and this will be a dictionary of I don't know what yet. And so from typing import any, and this will be VPC. Yeah, so what I'm thinking is ideally you need to give me configuration in this specific parsed pydantic format. If you don't do it, then you can provide me a dictionary with a configuration, or so maybe this is none. If you give this to me, so if you just give me like a dictionary that I expect, then I will parse it for you. Something like this. Now, yeah, no, probably not like this. Let's say if config data is known, I will... Oh, nice. They're actually trying to do this for me. That said, I think it should be like this. Maybe. We will try this out first. This is too much auto completion for me. Right, so this is a... So if you don't give me configuration data, then I will try to go to like my namespace. Alternatively, I then just parse it to this object and it might give some errors. And then I return a class where yeah, maybe something like this. So then I instantiate it. Yeah, I don't know. Like, I kind of like go against what Pulumi is doing a little bit. They have a very specific structure of like, okay, if you have a component resource, like give me inputs, right? So this would be like give me VPC name, give me internet gateway, and I'm kind of like no, I'm good. Give me a pedantic object instead. Yeah, it seems kind of like yikes a little bit. Yeah, I don't know how to make this abstraction good here. At least, like, I don't see fully in my head yet. Let's try to merge all of this and see like how far we can get. Okay, so kind of like, okay, like put this VPC configuration under this. So we have AWS region, awesome. Like this is just our test stuff. This I'm not sure will work, but I think we can check this first. I think I need to start somewhere. I think we need to first see if I can get this. Yeah. Let's see. What the hell is this? Oh, I see. It set a bunch of stuff. Yeah, this we can delete. This is bad. Let's just check if I can get this dictionary properly via pulumi.config. So can I retrieve this like this? I don't need this. I don't need this. I do want to print config. And then let's just raise an exception for now and see if this works. I'm not sure this will work. Oh no. Let's say what in VPC name. Let's say VPC name. VPC name. This works. Please work. Please work. Please work. I cannot tell. I don't know. Did this work? This is... So I see an exception, but I don't see this getting printed. Let's see what's going on in the chat. Erroner, you got DevNet Expert cert. Was it hard? Is it on CCA hardness level? I got DevNet Expert because I am the one who wrote it, so that's how I got my DevNet Expert. It is on CCA hardness level. I think so, yeah. Purse, conserve arc. Okay, I get a namespace. Okay, let's try this out. So the chat is saying that I need to do it like this. I suspect, yeah, it does seem it worked, but I suspect I need to debug it, right? Okay, I already have here, I think, yeah, I didn't save the file. Oh no. No. Yeah, let's go to the debugger and try it out. Those kind of things what I like programming language for, right? Like I can go to a debugger. In Terraform, there is Terraform console. I'm thankful it exists, but it's also a very painful experience. Like you cannot set a variable there in the console. Like it's just weird stuff. How do I do this? I think like this, right? And it should stop at the breakpoint. It should stop at the breakpoint. Let's say stack. Yeah. Config get AWS VPC. This didn't work. Is there like some kind of structure, like config dict name dmfigo? Huh? What the hell? That's like, I don't know. Is it? I will still try the VSVPC. Also structured configuration. Yeah, I was going through that. Like, I agree that I stopped following this. But I don't know. Let's try together. Structured config. Structured config is also supported, can be used, blah blah blah. And the pass flag. Yeah, like whatever. I don't care. I have this. How do I interact with this? Require object. Config require object. This is proj data. There was something else here. There was an example here somewhere of something else. Here. If you're writing code that will be imported into a broader project, such as your own library of Pulumi components, you should instead pass your library name to the config constructor to limit the scope of the query of values. Constructor to limit the scope of the query to values prefixes with the name of your library. Okay, I think this is correct. Yeah, so we have our namespace of like my library. Then I have a structured configuration. Yes, this stuff, to be honest, like a little bit confusing to me. Like, why can't I just do get on this? But okay, let's try to make this work. So like Pulumi config dmfigo config require object AWS VPC. Let's try this. Sure. Module object is not callable. Yeah, okay. Let's try here. So config dmfigo and then how did it call it? Require object. Require object. And then man, I just want the dictionary. How can I get my goddamn dictionary? So what VPC name? Oh. Uh, get object, not get set of require object. Okay, this did seem to work. Yeah, this did seem to work. What is what get object? Okay, is there a difference between get and require? I guess, okay, guess require just means that it must be there, right? Does get also work? Yeah, so if it's not there, it crashes. Okay. Uh, Pierce, are you working for Pulumi or you're just a power user of Pulumi? Okay, makes sense. Right. That's like, thanks for help. That said, like this, some of this does seem like it was pissing me off here. I just need my goddamn dictionary and that's it. Um, okay, we got it. So I can get a get object or require object. Okay, cool. All right. Okay, so I am at the point where I think I can pause this. I can do it from VPC is equal VPC from config data config. Actually, I don't need to provide anything because ideally it needs to be able to parse it. So let's go to our resource and find it here. Config data. Okay, if you provide me an empty config data, I will populate it from my namespace. I will parse it using Pydantic, and then I will create stuff. Now, I don't have here this app name environment. I need to think how I can get it. So let me think. Okay, so I have a folder structure. Like technically I could parse this config file path and extract these values, which is not horrible, but also I think like maybe not great either. I think you do need to give me an app name. Why do I care about this? Yeah, maybe for these examples we do need to wrap up soon because the videos that we are going to react is going to be in 7 minutes, so we do need to wrap up here for this part. So probably I will take a shortcut here and just like pass it along. So let's just say I will add it here, and then maybe like some other time I will think about what's the best way to do it. Like app name. So this way I can pass this around, right? So, and then I will think about like what is the proper place to put it in the config that is not directly related to like my VPC. Because like VPC doesn't know, like VPC module doesn't care about like what's your application or what's it is even your environment. It needs to have a name, right? But like in then outside of it, you might want to have like, okay, my format for VPC name is I will add application name and then I will add an environment or something. So yeah, I will have to think about proper abstraction for this and proper way to put these parameters. For now, we will just YOLO this a little bit because we like parsed it from, like in this case, stack name. How do we even know the stack name? Is it because we specified it? Where did we specify stack name? Okay, we specify stack name directly on the CLI, so that's how we parse it. Okay. No, I don't need to provide anything, right? Like this. Okay. Let's see if this works. Let's see what our chat says. What's your weapon of choice for Pulumi? I put Python on everything. I put this shit on everything, you know? This kind of meme. I guess it's just like I know Python the best. Thanks for leaving recording on Twitch. I couldn't follow because of time zone difference. Fun, you can go to my YouTube channel and see there. Pierce is why I don't use Python in general. Like, I don't think it's a Python thing. To be honest, here specifically, I don't necessarily like some of these abstractions regarding this Pulumi config stuff. Okay, why this didn't work? Because it's obligatory parameter. Yeah. How we are not doing great on time because the Kelsey Hightower thing is going to start really soon. Will this work? VPC init requires positional argument name. Yeah. We need a stock name for this. Oh no. Yeah, I think it... Yeah, like some of this like naming stuff needs to be thought through. Like what is responsibility of the module and what is responsibility of outside of the module. Okay, we are getting somewhere. We are getting somewhere here. Pierce TypeScript. Okay, yeah. Yeah, I guess both TypeScript and Python are very popular, right? For Pulumi. And I guess in general for DevOps people. Like now that I'm thinking about, like, to be honest, I would say majority of DevOps folks I've been talking to, they either do Python or Go, right? I actually rarely see their TypeScript. Yeah, Python because of DevOps. Yeah. Okay, so this seems like it's working. So that's good. Now, yeah, and we like look at this. We like recreated VPC. it's part of the new namespace, like this dmfiggle fancy namespace that we got over here. Pierce, I think it really depends a lot on about like who you're talking to, right? Like, like full stack. There are many full stack devs who like use JavaScript or like TypeScript on both client and the server, and then like I don't know, doing some Next.js or whatever. And those folks, maybe they like using some like additional infrastructure, and then they're very familiar with it, so like they want to keep using the same thing. So that would be like one part of the spectrum. And another part of the spectrum, like maybe like bigger enterprise infrastructure with like specific DevOps SRE teams who build like VPCs, EKS cluster, things like this, where like they don't develop applications, right? The users are internal users. Okay, let's we are wrapping up here with Pulumi stuff for today. Let's just see in the console. Where do we see this? So the stack is deployed. Look at this. So I have here a stack. I have my fancy VPC module. We created a bunch of subnets with multiple CIDR blocks. All this stuff is created. And let's see it in the console. Which, yeah, my access expired. So like I will see it here. Yeah, VPCs. And we are late for our stuff. All right, so yeah, our production VPCs here with 2 CIDRs. Yeah, so all this is good. I will have to think about like how to arrange some of this stuff properly, because I don't like some of this. Yeah, okay. So folks, thank you for sticking with me with Pulumi. So now we will go and react to Massdriver thing with Kelsey.
Else in the team to do anything with that?
Could you let me know if you can hear them?
All the nuances between where variables go, how to fill things in, and my guess is the majority of people don't have validation. Right? You may have something like string versus a number, but you don't think all of those things. So to kick us off, we're going to start with like the state of the things. I'm going to introduce one of the co-founders of Massdriver, Corey, to the stage. Try to go over the state of things, and then we're going to pivot immediately to a live demo and then Q&A. So with that, I'm going to welcome Corey to the stage.
Thanks, Kelsey. Go ahead and move you real quick so I can add my screen. So I promise only 2 slides. Let me go ahead and get this up here real quick. So as Kelsey mentioned, I'm Corey, one of the co-founders of Massdriver, alongside Dave and Chris, who will be on the stage in just a minute. We're also proud to be one of the companies behind OpenTofu. When HashiCorp relicensed Terraform, we knew the community needed a truly open source alternative, one that upheld the principles of transparency and collaboration. Between the 3 of us, we've spent decades in ops, DevOps, and platform engineering roles. I've been in the space since 2000. We've worked for startups, enterprises, and everything in between. And everywhere we've gone, we've seen the same frustrations. DevOps workflows that are supposed to empower teams instead create bottlenecks, complexity, and this like constant sense of firefighting. And Massdriver wasn't born from a grand plan. It was actually me and Dave were working on a completely unrelated side project, and we just had this weird moment of truth. We got to the point where we needed to set up our infrastructure, and we're kind of staring at each other, and neither of us wanted to do it. Right, like 2 seasoned engineers, decades of experience, right? And we were trying to avoid the boring part, right? Both of us wanted to build the product. Why? It's because it's the grind that we all face day to day, right? Duct taping 1,000 tools together, wrangling IAM policies, endless YAML, diagramming compliance, security, like the whole slog. And we knew what came next. One of us would get pigeonholed into the ops or DevOps role. Like they'd start to get frustrated. They wouldn't be working on the product, right? And that's when we kind of realized like this wasn't our problem. It's the problem. It's like the problem with our industry in the cloud, right? And the data backs this up, right? Not to get too nerdy into some reports, but the State of CD report showed only 27% of orgs are even using infrastructure as code, with no growth from 2022 to 2023. And the 2024 report showed that no developer group, based on experience, had
Hope
more
you'll
than
get the
21%
demo soon.
adoption. And like, this seems crazy, like when you're doing this day in, day out, because it's all around you. But most organizations aren't as mature as many of the people probably on this call. But forget the numbers, right? Like, we feel this every day. Operations and DevOps teams slowly get dragged towards ticket ops as developers get frustrated with infrastructure as code, or they try to deliver self-service and you get buried in tooling trying to track down infrastructure diff because devs don't like the experience. This just tells us that something's fundamentally wrong about the way that we're approaching infrastructure as code. It's supposed to be essential, yet we're not seeing widespread adoption because the barriers are too high. And I know many of you face similar frustrations.
There will be a demo,
Self-service tools
seems like
promise
Q&A.
to simplify workflows and
So
only end up adding
let's
more
ask
complexity
difficult
and then
questions.
less visibility for you as an operations engineer, right? When you give the developers keys to the kingdom, you don't know what they're making anymore. So let's talk about GitOps for a second, right? It's positioned as the ultimate way to manage infrastructure, right? But for infrastructure as code, it creates more problems than it solves, right? Here's the paradox. Infrastructure as code is something that all teams need, but few teams are actually using it effectively. Why? Because it demands too much expertise and adds overhead to shipping features. Imagine you're a developer and you're working on an avatar uploader or a CSV uploader, right? You need a bucket. You just need a bucket to put some files in. And it's straightforward from the code, right? Maybe I'm a node, I got S3 put, file name, done. One line of code. I'm putting stuff in buckets. But then I have to handle the infrastructure. I have to define the S3 bucket in Terraform or OpenTofu. S3 is the most complicated configuration interface in AWS. We're talking about 10, 20, 30, 40, 50, 120 attributes just to configure a bucket. That's not counting the IAM roles, permissions, compliance, security, cost policies, making sure it all integrates seamlessly. Suddenly I've got one line of code for my feature, and I've got 100 lines of YAML, a few hundred lines of Terraform.
Yeah, because infrastructure is complex.
And suddenly, you're not just a developer anymore. Now you're an operations expert, right? When GitOps is your platform, all operations tooling from IAC to the walls of YAML to policies become the developer's problem. And instead of embracing the principles of DevOps, this approach just shifts the responsibility and tooling burdens on the developers, who are left navigating complex workflows, firefighting, instead of building the features that make the company money that pays all of our salaries. And even when developers ship quickly, operations teams are left with the long-term maintenance, exacerbating the silos and creating more friction instead of solving them. This is why we feel that GitOps fails to meet the real needs of teams and why infrastructure as code adoption just continues to stall. So the three problems that we see with the current state of infrastructure as code management is, one, starts with discovery. Like just finding the right module is hard, right? Let's say that my company has done a great job of organizing our Terraform or OpenTofu. We've got a Git repo for every single module. Now I'm searching around in GitHub trying to find it. I find it, great. I go add it to my main TF in my application repo. I copy a wall of YAML, and I've got a Postgres database. But how do you, as the operations engineer, know who uses that module? You're in the exact same problem. You're through repos trying to figure out who references your shared module, right? Reviewing the changes sucks. You're hunting through PRs and logs. This is why every cloud provider has CLI tools and UIs. They don't just have Git integration built in, right? It's not enough. And the second is, there's no pre-authorization or validation, right? Developers struggle to make safe changes without stepping into compliance and security traps, right? It's that Homer Simpson meme where you're just stepping on rakes left and right. There's no way to pre-validate your configuration. So the only option is trial and error, right? Resulting in failed pipelines, wasted time, and frustrated teams. I make a commit, I set a config, 20 minutes later, Chekhov in CD somewhere tells me I did it wrong, right? And a UI built with pre-authorization, like what we're doing with Massdriver, enables developers to safely self-serve within guardrails that actually enforce your business constraints, not just before something goes live, but by preventing invalid configurations right from the start.
I want to see
And the
what
third one,
exactly
and this is
he
the most
means,
important,
but
right? As
like
developers
so
and
far
operations
not fully
engineers,
resonating with me.
only like 10% of our jobs writing code. We're reading it a lot more than we're writing it, right? And the documentation is just lacking. Git isn't documentation, right? We store some code there. So you end up relying on tools like architecture decision records, Notion, putting some stuff in lucid charts. You don't have a clear picture of your infrastructure. You have a patchwork of tools and poor visibility, right? If you've organized your Terraform well, you've probably got some networking stuff over in a networking repo. You've got your clusters somewhere in a cluster repo, and then each
Yeah.
of your application developers has their own infrastructure, right? There's stuff spread all over the place. And a UI that solves this by making the state of your infrastructure instantly understandable without sifting through commits after commits or maintaining separate documentation just
Like
makes this so much easier for
again,
everyone.
I want
So
to
the
see
question
this.
we
Like
ask
System
is
Init has a
how do we make
better, I think,
infrastructure as code work
perspective,
for
but I don't
everyone on the
think they
team,
are doing what
whether
System
you're an
Init is
operations
doing.
engineer, a developer, or maybe somebody who's a manager or in QA that just wants to understand the system. How
Like,
can we
you know, like
deliver
here, for
self-service
example, you get the
infrastructure that
graph
lets
in
developers
Pulumi,
ship
right?
faster
I think Terraform
with
Cloud does similar
all
thing,
of
but
the benefits of
see.
IAC and GitOps, but without turning them into an operations expert
Documentation's
or
an
binding them in
afterthought.
red tape?
Mm,
At Massdriver, we're challenging these norms by building tools that simplify infrastructure without compromising control. Instead of just talking about what's possible, we want to show you how it works in practice. So I'm going to hand it over to our CTO, Dave Williams, to walk you through a demo that takes these ideas from concept to reality.
Chat, what are we thinking so far?
Okay, let me go ahead and
Like,
remove myself.
am I the only like skeptic or no?
Hey, thanks, Corey. All right, let's walk through kind of how Massdriver works and kind of our vision for what moving from reactive operations to proactive operations looks like. So you can see here my screen. This is Terraform. We know it. We love it. We've written it a million times. This is kind of the scope of a Terraform module. So what we're building here is a DynamoDB table. You can see it's just a DynamoDB table resource. I have an IAM file here to define clearly split read and write actions, right? Because I, as an operations engineer, understand the IAM, and I don't want to leave it to chance that the developer doesn't just do star. You can see here, when I write Terraform, I like to add some basic alarms. This isn't a requirement of Massdriver. It's just a thing I like to put in modules because I kind of understand how this works, and I'm in a position when I make this module to create some kind of base alarms. Now, this is Terraform we're looking at, but it doesn't have to be. Our goal here is to optimize the role of operations. So making the decision on your IAC tooling is not what we want to do. Where we actually come in is a step above this, and we provide a specification we call the bundle specification, and it does a few things. The first thing it does is provide a metadata API, so you can actually catalog this module and make it discoverable within the Massdriver UI. Right? No more hunting through GitHub repos and hoping you type the right incantation to find the modules in the documentation. The next thing we do is we provide a state-aware param schema. What this schema is a JSON schema with some extra special sauce that lets you define the parameters that developers are actually going to be allowed to use in your module. Right? This is going to create the visual interface in Massdriver. And that state awareness is going to allow you to prevent people from doing things when something's deployed versus when they're deploying for the first time. The only thing to know right now is it's JSON schema. It's industry standard, very easy to pick up and learn. The last thing that Massdriver does is we define a series of dependencies and outputs that we call artifacts and connections. A connection is a dependency to a module. You can
basically
see here,
like
in order
stack
to deploy a
reference or something.
DynamoDB table, I need some type of an IAM role, right? This is actually going to be used to then deploy this module into the cloud. When we've created our DynamoDB table, we're going to create a type of DynamoDB table. All these are structured JSON, things like the resource name, those policies that I've created. And this is going to allow downstream modules to pick the policy they need and connect back to this module. You could imagine if it's RDS, this might include a security group so that we can securely connect back to our database without Swiss cheesing our VPC. So once you've kind of settled on this bundle specification, you will mass bundle publish. Wrong directory, bundle publish. And you will go into our platform. So now your developer needs one of these DynamoDB tables.
Okay, so
We'll type
cataloging part
DynamoDB,
is
he'll
actually, I
drag it
think,
onto the
pretty
screen. They can
cool.
give it a contextual name like user sessions and add it to the canvas. We're going to look at one that already exists here, though, because it's going to have a lot more information for us to explore.
Like
So if you're in
this
the
part
platform,
does
we
resonate with me.
select this
Like,
DynamoDB table and we go to config. This is the result of that param schema. This is what your users will actually interact with, your software developers. You'll see here, US West 2 is a disabled field. This is disabled because if a user were to change it while it's deployed, you would end up deleting and recreating, losing a bunch of data. We don't want that to happen. This is an operational constraint in the cloud. It is a dangerous action when something is deployed. We can be proactive here in preventing people from making mistakes in the cloud. If we look at our Aurora Postgres here and we select the version, you'll notice we actually can't downgrade our version. Again, this is a caveat of the way that RDS works. If we downgrade, we delete and recreate.
this would so be solved with was terraform policies,
For us to
and I
front-load if
suspect
we're gonna
Pulumi
get around
policies
kind
as
of that
well.
constant code review and red tape of DevOps.
Folks, is this correct?
Now, outside of operational constraints, things in the cloud that you shouldn't do, your CTO, your CFO, your CISO, they all have opinions about the way that we utilize cloud infrastructure, but they can't be in every PR to enforce these. We need some way to, again, be proactive in enforcing these constraints. So you'll see here, we're in provision mode for DynamoDB, and let's say we have a developer that says, I want 5,000 read capacity because marketing is going to send out an email. You'll notice if I click save here, I was prevented from doing this. Now the AWS, let me remove myself from the screen.
Yeah, like this is like policy stuff on your constraints. Okay, so like you can even do it with Terraform.
The AWS limit is 3,000. This is something that's really easy to miss in a PR. Because when we're doing PRs for infrastructure as code, very rarely we're going back to the cloud APIs and actually looking up what the limits are. You'll see here, when I try and use 5,000 as a value, not only am I saying you have to be less than 3,000, I'm saying you have to be less than 400. And maybe that's because as an organization, we've decided it does not make sense for us to run read capacity higher than 400. In the event that we're going 400, we should be pay per request. And you notice as I change that field, those two dependent fields disappear, right? This is kind of guiding the user on how to actually configure this, right? In Terraform, we're looking at a wall of attributes, and how those attributes are dependent is generally unclear without really knowing what that module is capable of and kind of going through the documentation. Again, slowing down your product engineers.
Okay, so I think it's like dependencies between like variables. I don't know if you can do it with Terraform on its own, but
they can
like in Pulumi code,
we're going to
pretty
use that
easy.
IAM role to roll out this exact code that we had pre-approved and published into Massdriver. While this runs, I'd like to show you some of the things we still love about GitOps and we don't want to get rid of. You can see here, every time we deploy this DynamoDB table, we actually take a snapshot of every value that was within this configuration. We allow you to compare across points in time so that we don't lose the visibility into how our infrastructure evolves and what people are doing. Right?
Yeah, this is inputs, really like the
rollback strategy in the event
GitOps would solve this the same way. Like you div between commits. Like
so
I don't
the last
see
piece
a
of that
difference
bundle
here.
spec that I talked about was inputs and outputs. And you can see here, this DynamoDB table outputs some structured JSON that we've defined as a DynamoDB table. Our application here, if we hover here, takes a type of DynamoDB table. Now, because we use structural and nominal typing, we have the ability to kind of look ahead and say, this can only go in one place, and this chat app is dependent on an AWS DynamoDB table. Now, the truly amazing thing about this is
so I think
this part is native Helm, and this table over here is Terraform, as we just saw. By making them both speak JSON, we get interoperability of our tooling. So no longer are we constrained by our ability to educate our product engineers. We can use the right tool for the job and provide the exact same user experience for our engineers that they get using Terraform, using Helm, or using Pulumi. So that's kind of an overview of what our platform does. I'm going to hand it back over to Kelsey.
Kelsey.
All right, look, I'm back on stage now. So look, we got to dive into some details. I'm not going to let you off the hook quite yet.
All right.
So one thing about these various configuration tools, at least when I started doing config management, like 2010, in 2012 I worked at Puppet Labs, and all the rave was like literally configuration as code. Like you would take Python or Ruby and you would make these kind of islands of config, and none of the tools are interchangeable. No way. You start over every time you swap. When Kubernetes came out in around 2014, 2015, the thing that was dope to me was that we were moving towards configuration as data. And a lot of people still can't grasp this concept around how do you make these things interoperable? Like in real apps, when you write real code, you don't pass Python and Golang and Ruby and Java across the wire. I mean, you can if you're using some type of RPC thing, but those don't tend to interoperate. So we've standardized on things like JSON in between. And what I'm seeing in this demo is you're saying, look, let's treat Helm and Terraform in some ways like their own little services that have defined APIs, meaning they're not going to just be used by the Terraform command line tool. There's an assumption that we don't know what the thing downstream will be. And so in that case, we just create a real API that has inputs, constraints, error checking, and predictable outputs. So what I want to do is dig into that Helm chart. A lot of people on this call may be used to Helm. They've used it before. Helm has its own way to think about variables, but a lot of people probably aren't connecting the dots between like Terraform and a Helm chart. So if you could, maybe pull up that Helm chart and show where that reference is happening so that you can actually draw the line.
Yeah, let me download it from our package manager here and do just that.
And while you're doing that, for most people, the thing that made me dope about when I saw this, like I am not a fan of ClickOps. I've seen a lot of visual editors attempt to do things that configuration management had left gaps for. But the thing that I thought was dope about this was giving people the API layer to infrastructure as code so we can actually start doing this like you would do if you were doing development or if you were a cloud provider. We put APIs in front of things instead of giving people raw code.
All right, just one more second, pulling it from the package manager.
The package manager concept, for those that are thinking about that, when I first saw this demo from the team last year, it was around this concept of if I already have Terraform, I am not looking to start over, right? I don't want to pick another config language. It took us a long time to get to this point. How's this layered on top of? And I think earlier in Dave's demo, the first thing he showed you was the same Terraform that you're writing already. And if you take that Terraform and you think about what would an API look like if someone wasn't necessarily using the command line tools from HashiCorp or necessarily knowing what Terraform is and how TFVARs are structured, what would you do instead? Well, you would create a real API. And so that could mean like, I don't know, creating your own RESTful API and shelling out to Terraform to invoke things. Like that's one way of thinking about it. But in their model, they just turn these things into bundles by wrapping metadata and JSON schema on top. That's how you're able to start interacting via a UI. And I don't think Dave showed this in his demo, but there is a concept of the Massdriver API. So if you actually know how you want things to go and you can connect the dots yourself, you can use the API instead. There's a question that popped in. I'm just going to answer it in real time while you're pulling that up. Can input constraints be done using HCP Terraform policies, right? So this is a good question. One thing that I think the HashiCorp team did over time was realize that you just can't give people wide open fields to do whatever they want. So this question from Dimitri, can input constraints, can they be used to be using can input constraints be used via HCP's Terraform policies? If you want to answer that real quick, Dave, or anyone else from Massdriver want to jump in and answer that question.
Yeah, I'll jump in real quick and answer that. Technically, you probably could use. What we try to do is the same way that we look at interoperability between IAC, we try to approach even things like policies and compliance in a way that's a bit agnostic to the specific tools. So, I mean, you could use Terraform to check and put compliance or constraints around Terraform specifically. But particularly around their variable, it's a bit limited in what you can do. And two, it's not going to translate
Nah.
over to when you want to use Helm, or when you want to use CloudFormation, or when you want to use Bicep, or when you want to use any of the other tools. So it's going to be that's going to be very, very specific to Terraform.
Okay.
Yeah, I think another big thing to think about here is that I don't know people that are trying to use Terraform for everything. No, actually, I do know people that are trying to use Terraform for everything.
Okay, if you use
start to arise.
multi-tools,
So for me,
maybe
Terraform bootstrapping cloud provider infrastructure, right? Create the VMs, create the VPCs, totally makes sense. If you've ever tried to use Terraform to configure a single server to run an app, you already know that you're in a weird situation, right? When Terraform isn't confronted with a clean API, things tend to go left. This is why they have those provisioner steps, right? Like, hey, the VM is up. Here's a collection of scripts you should run that tend to do something, right? No problem. But then I saw people trying to use Terraform to manage Kubernetes clusters. And this is equally insane because what you tend to do is just mapping HCL to JSON or YAML. Because all Kubernetes understands isn't commands, and you don't poke at its API the same way you do like you do in a cloud provider. You're typically boiling out the entire state of an object. And then when you hand that object over to something like Kubernetes, which has its own configuration management system, a lot of people don't realize, all those emission controllers, they can actually modify that input that Terraform is giving you. So now there's a blind spot. Terraform is giving you a subset of the data, and then it can be manipulated where service accounts are appended, things are transformed, and the honest truth is, only Kubernetes knows the actual state of the object, and those status fields, what IP address you got, that's only in Kubernetes, right? Maybe you could try to write a Terraform module that knew how to extract that information and make it return as an output, but you're definitely missing constraints. You're missing all these other things. Now let's get to the heart of it. What happens when you start using the right tool for the job? Like you say, you know what, let's start using Helm for the Kubernetes piece. So Terraform creates the cluster, configures all the low-level details, IAM roles, etc. But there's a richer ecosystem of Helm charts that are a little bit more compatible with the way Kubernetes does things, understand how to reference other objects, but it also limits that it may need information from the Terraform layer. Which cluster should I be using? What zone am I in? Where is the DynamoDB database that was created outside of Kubernetes even being existing 2 years ago? Wouldn't it be nice just to reference something that was going to give you a clean entry point into what the bottom layer did? So whether you're using Terraform or OpenTofu or hell, Pulumi, like, does it really matter as long as that thing exports a reusable API? So that's the game changer part. So when I said rethinking infrastructure as code, I'm not talking about drag and drop GUI wizards connecting dots. That part is actually cool too.
Chat, what are we
It's
thinking?
nice when that part works because of the stuff in the middle. Actual validation, an actual API. We haven't even talked about generating documentation, generating cost controls, all the other things that come with the ability to do that once you have an actual schema. So the leap between Docker and Kubernetes was the fact that we gave infrastructure a type system. We gave you a specification. We gave you value to those meanings. The thing that Kubernetes left on the table, though, was relationship between objects. There is no relationship between objects in Kubernetes. Hence, Helm was born in an attempt to try to create relationships through objects, through templating. But even in that world, you got to go learn Go templating language, and then how do you even consume it? So if you have a bunch of Helm charts, right now, if I asked you, go find the Helm chart approved by your company, good luck with
No
that.
idea.
Yeah, so what we're trying to do is just move into a new world where we take all this code and turn it into something that's reusable with a well-defined API that has constraints, and not just do it for Terraform. Do it for Helm charts, do it for anything that makes sense at the right configuration layer, and once you have all of that, then surface the tooling so people can interact with it, right? Some people just use the API if they understand what these things mean, but a lot of people, if you're like me and I don't understand what your configuration setup is, it is nice to be able to drag a block onto a canvas and say, what can I do? And for you all that say you would never do that, I know you're lying, because I used to work at a cloud provider, and most people's interaction with the cloud starts with the UI to to learn what they can and can't do before they start writing infrastructure as code. So with that, we're going to go straight to the Q&A section. It looks like Dave is good to go now. So Dave, come on back and maybe walk us through a little bit, because I'm pretty sure a lot of practitioners on the call are used to using tools like Helm and Terraform. Maybe we can dive into the code a little bit.
Yeah, absolutely. So this is one of our older modules. We're still leveraging Terraform for the actual Helm apply. We have a Helm provisioner you can see in our repository, but you can see here we're just using the Elixir Phoenix chart in our Massdriver Cloud GitHub.io Helm chart repository. But if you can see over here, for the Massdriver YAML, this becomes purely opaque, right? Because we have formalized the idea of user inputs, system inputs through artifacts and connections, right? And kind of like application level concerns like environment variables. We've created a common language for both Helm and for Terraform. And so you can see from an operations perspective, we get the exact same kind of experience here. We can set a log level, but instead of a person guessing, is it, capitalized, is it, warn, is it warning, we can actually like set these for our users to make it really, really easy for them to understand their kind of applications. But again, the magic here, the thing that enables these two things to talk to each other is this connections block here. We need a Kubernetes cluster, we need some kind of a Postgres, and we need some kind of a DynamoDB table. And then we have no outputs on this because it's publicly available, but that connection system is actually what allows us to consume those dependencies from Terraform.
When I was at Puppet Labs, back in like 2012, 2013, there was a guy that used to work there named Ari. He made this tool called mCollective. And what mCollective used to do is when you did your Puppet runs, each individual node had all this data about itself, and there were other nodes that sometimes needed to depend on that. So you run mCollective, and it would try to go gather all of this data, so that way it can be referenced by other nodes during the run. You can imagine the race condition here. The truth is, I think most people want it with something like this, which is like a data mapper. Here's what comes out of this other thing. Here's all the constraints. Here's all the schema. And then also, here's what I'm expecting. And once you do that once, so if some of you look at this like, oh my God, Dave, this is more YAML. And the truth is like, yeah, you got to describe the inputs and outputs once so that other people don't have to think about it.
Yeah, exactly. And this can go a lot deeper, right? So you could imagine making an RDS bundle that said, I don't want a VPC unless it explicitly has private subnets, right? To constrain users from deploying an RDS into public subnets, right? And so this becomes really, really powerful. With just a little bit of YAML, you can enforce some serious kind of security and compliance guidelines without the user having to be concerned with them.
The better way to enforce those constraints would be in the cloud.
Besides TF modules, what else can Massdriver manage? So I think we've seen Helm charts so far. We've seen Terraform itself. Is there any other things that can fall underneath this umbrella?
Yeah, so again, our goal was to make a generalized wrapper for running any binary. So by default today, Terraform, OpenTofu, Helm, and Bicep are all supported. We have early betas of CloudFormation, but you can also build these yourself. Our provisioning engines are simply Docker containers that have standardized places where we put that JSON coming in. So it's really, really easy to make a Bash or a Python provisioner if you still want to run Bash and Python scripts.
Is the best way to think about this, like, I remember when I discovered this fact in Jenkins, right? There are some steps like, hey, here's a build artifact.
Is it like CDK, but for
I could just
Azure?
write a bash script that takes in this URL input back in the day.
Or CloudFormation.
Rip out that URL and then do things with that binary. Are you saying here that, hey, once I add my own provisioner, can I just...
Let's say it's more like CloudFormation, right? Separate language.
Comes in. If I understand what that blob is, I can do whatever I want in the middle. I can go and create a whole new Kubernetes cluster, tear it down. But when I'm done, I output some more JSON that can then be used downstream.
Yeah, the idea is that when everything kind of understands and speaks JSON, you can make arbitrary workflows and architectures using whatever you want, right? And that's kind of the missing link right now with GitOps, where it's a kind of this one-to-one process of like open a PR, approve a PR. build a pipeline to deploy whatever's in that PR. And we're kind of trying to get around that by being able to like build reusable pipelines that understand JSON for your various IAC tools, so that you can focus on adding value by actually building the infrastructure and the modules.
You know, I think sticking to that analogy, what I think a lot of people forget is the thing that made software so interoperable was when we started cutting actual releases with versions and put APIs on them. So before we did that, it's just like software on a server, and you ran make build on the server, and you just interacted with it based on however it worked. Now what we do is we say, hey, no. We're going to cut a release of the software. We're going to version it, aka create a bundle, and then expose an API with docs. And you will interact with that release through that interface, right? Don't worry about getting raw access to the source code. Do not worry about being deployed on the same server. So in this analogy, it's like, don't worry about installing Terraform before you can interact and participate in leveraging the code here. We had another question, which was, how can I integrate Massdriver? Is there an API? Is there a CLI tool? Because I can imagine people say, hey, this UI is dope, but man, I got CI/CD that wants to interact with this stuff just the same.
Yeah, so there's a couple of ways. All the validation mechanism using our bundle spec is actually open source in our CLI tool. So if you only wanted to kind of run Massdriver bundles, you could use our tool called Airlock in our CLI to get that kind of JSON input validation in GitHub or something like that. Obviously, if you're using Massdriver, we have a full GraphQL API in our CLI and some GitHub actions for you to actually deploy through Massdriver. So you have a couple of options there.
Yeah, so if you want to skip the UI, you can continue to do that. There's a couple of ways of doing it. So go check out some of those. And I think we're going to provide links, so we'll probably drop some here in the comments or on YouTube as a follow-up. There's another question from the audience. I think I'm going to grab it, and then I'm going to go to some of the ones that we had ahead of time. For now, this seems oriented to applications. But what about the platform itself? Is Massdriver able to provision and configure? I'm thinking about Ansible here, the platform on which apps were to run. So I think to clarify here, I think the struggle with all of this tooling, if you were in the Puppet world, Puppet was very much node oriented, meaning that you needed something like VMware to create the VMs, and once they were in play, the Puppet agent could then now be controlled through the Puppet DSL. If you're using Ansible, the Ansible agent needs to be installed, and you can SSH. Again, node oriented. Terraform comes along, and it was like the first time we felt configuration management be infrastructure oriented, meaning if the cloud provider exposed an API or your VMware local install exposed its API, then Terraform itself can create storage buckets, NFS volumes, VMs, VPCs, the whole nine. And then when it gets to the application side, we were all left scratching our heads again because apps tend to need something slightly differently, unless it's like an infrastructure-driven API like serverless. But Kubernetes needs something like Helm that is hyper-specific to the app layer on top of the infrastructure. So I think the essence of this question is, in Massdriver's case, what if I'm not really thinking about deploying apps yet? I'm not quite ready for my developers. We're just the operations team doing our DevOps thing, writing a bunch of Terraform, but we have the exact same problems. Does Massdriver makes sense if I'm thinking about just setting up VPCs, IAM roles, VMs, et cetera, et cetera?
Absolutely, and that was actually our first use case in our first prototypes was, how do I get the infrastructure there? And I'll deal with my app later, right? Can I get a Kubernetes cluster, a database, a DynamoDB table, and I'll deal with making a container and putting it on Kubernetes in some traditional CI/CD that I was already familiar with. And what happened was managing infrastructure through Massdriver felt so good.
Hey, Mark.
There was no reason not to manage that Docker container deployed to Kubernetes, right? That application artifact deployed to a VM we created. So apps kind of came in afterwards, and it's been really good. So yeah, I think if you start with infrastructure, it makes a lot of sense, but I would recommend your apps too.
Go back to the UI really quickly, because I know a lot of people like details, right? So we said a bunch of words. Maybe we show people. So let's go to a clean canvas for a second, right? So let's just say someone watches this and they say, hey, you know what? I'm super interested. I want to go create dev, right? Or a little staging environment. And so let's just walk through this as like a new user who's thinking about creating that new environment for the first time. I got a bunch of Terraform. I watched the demo. I've wrapped all the things Massdriver asked me to. Now that thing is ready and available in the catalog, right? So we go to the catalog.
Yep.
I'm
right.
only interested in infrastructure at this point. Let's just say I'm using AWS. Maybe I need a VPC, or maybe I just want to start with a bucket. What am I doing on my first iteration now that I got a bundle available in the UI?
Yeah, so here's the interesting thing about having that type system, right? We can kind of work backwards. So you don't actually have to think about VPC necessarily, right? We can say we want a Postgres, drag it on, call it database. You can add it to the canvas here. And you'll see, because I understand dependencies, I can actually work backwards and now give you that VPC, right? One of the things we do in demos a lot of times is drop an app on, because the app defines its dependencies. It can work all the way back. So if you're just doing infrastructure and you have kind of a couple of bundles that are dependent on each other, you can now just focus on configuring what you want your VPC to do. So maybe we just want a kind of a small network here in the US East 1 region, right? We can then deploy, right? So we're making a dev. We have a dev preset to make a small network, and we can deploy. And now we can
That
focus
seem like
on what our
they run
database configuration is.
terraform
And again,
for you, right?
we can start to build these presets using that Massdriver YAML and say, all right, it's just a dev environment. We're going to give it a dev setting here and deploy the same way.
I'm gonna be honest with y'all, I ain't seen this before. This legit though. So think about it just for a second. Right now, that makes all of this stuff hardest. We have no connectivity between any of the layers. You just gotta know what needs to happen. You gotta remember to create.
There
the
is
VPC
something
first.
about it that
What
I
values?
like,
You
but
have
we'll
no
discuss
idea.
it
So what
later.
do? We just start creating VPCs that have all the stuff you may or may not need in it, because you're trying to create blueprints just for the VPC. So then when the database thing shows up, you're hoping that the VPC config is big enough to accommodate the database or the unique needs of the database. I hope you understand what you just saw. You bring in the database module. So this would be the equivalent of just magic happening in the Terraform command line tool. I go get the database module, and then Terraform just generates the other dependencies for me. That's what would have to happen in the existing world. And so when we show this particular approach, I hope you understand now that once you add a type system to it, you can start to generate things and then have them actually work. So hopefully that answers the question, can you use it for operation stuff? The answer is clearly yes, but the thing that we want to talk about really is that to make this stuff operational, right? When you buy a raw server from like Dell, you got to make it operational. You just don't put a random OS on there. You configure the OS and the users and make it operational so that when other people log into the server, they're not installing random things and creating random users. That's the equivalent here. I'm going to pause for a second because we have 23 more minutes. So I'm going to go to some of the big ones in there because there's other people from the Massdriver team that have been working on this stuff for a long time. One of the big questions that come up is around this idea around self-service, right? And maybe, Dave, you can jump in here. What is it like for teams to actually adopt this? Because we're showing a lot of kind of ClickOpsy stuff, and hopefully people understand now this is not ClickOpsy. This is kind of type system generated structure being added to the Wild Wild West to make it usable. But Chris, if you want to jump in, what is this like for actual customers that you've been working with that see this for the first time and say, yo, we actually want to start using some of this ourselves? What does that journey look like for them?
Sure. So we see customers that kind of come from a lot of different situations. Some of them are already operating in the cloud, but they want to really streamline and improve their process of managing and deploying IAC or reduce the friction between their developer and ops team. We see some that are actually coming from a data center or a PaaS or something like that. And I think one of the things that helps is a lot of times companies will assume that if they just adopt IAC, suddenly everything in the cloud is going to be a lot easier. And I would say that once you adopt IAC, you actually inherit a whole lot of new challenges and new problems. Like you have the benefit of IAC of reproducible infrastructure and stuff, but you have new problems around who's going to run your IAC? Where are you going to run your IAC? How are you going to audit, changes that happen to it? How are you going to break up different environments so that you can properly replicate without breaking things? Where are you going to store your variables? Where are you going to store your state? How are you going to manage your state and prevent state lock? And so you inherit all of these new problems just by adopting it. And so I think a platform like Massdriver really helps you immediately solve a lot of those problems, in ways that I think are intuitive and will help your team, both your developers who need the infrastructure and your operations team that is likely the ones that are writing the IAC and maintaining it. You now have this kind of shared collaborative platform where you can publish IAC, make it available to your organization, and developers can take and deploy what they need, and they don't have to worry about, am I violating security strains? Like, how do I actually configure this thing? That you can build these things in as an operation engineer to really make it easy for everybody in your organization to kind of assist you in building and maintaining the infrastructure. And you can now focus on specifically, how do I leverage my expertise and give it to the organization instead of just focusing on ticket ops? How do I update a bucket lifecycle settings? How do I, create a VM? Now I need to tear down the VM. You can focus on giving to your organization things that are actually going to help everybody, not just day-to-day work.
So the big thing here is separation of concerns.
Mm-hmm.
Learning Terraform, learning Helm charts is a necessary skill. If you're doing platform engineering, you got to learn them. The trick is, though, don't force everybody else to.
Yeah.
Put on top your constraints. Figure out what you want the experience to be. All the policies that are written somewhere in Confluence that nobody reading, put that into the metadata. Put that into the bundle spec. That way, when you then publish, hey, y'all have access to do these things, you don't need to ask me whether I can do 200 or 300. If it works in that UI or the API, then you can do it. Because if I don't want you to do it, I won't make it possible. That just changes the scale in which you can move, actually. And so I want you to really think about that. So I'm going to pivot to rapid fire.
I'm not fully sold, but there is something interesting there.
So let's go into it. So I'm going to basically let everyone rotate around. So I'll call out who wants to answer first, and then anyone else can follow up. So the next one is Massdriver focused on cloud-native solutions? Does it also feature parity for legacy-based VM solutions? Right, so maybe Corey, we start with you, and then we'll rotate in if anybody else wants to jump in. So I'll start with you, Corey.
Yeah, we do support VMs as well. So the only limitations of Massdriver is what your IAC tooling is limited by. So if you're using Terraform to manage your VMs, you can use Massdriver to manage VMs. And we're actually doing a pretty large data center migration with a customer now who is using AWS migration services to take all their VMs on-prem and push them into VMs managed by Massdriver through OpenTofu.
Yeah, that's dope, because I think the key here is I don't even use words like legacy versus modern anymore. It's all roughly the same. Spending 7 years in
Everything is legacy.
The one thing customers cared about the most, make the new thing.
The second you deploy something, it's legacy.
And really what this means is that let's just put an API on top of infrastructure. So if you have some existing money-making infrastructure, much better phrase than legacy, then if you put an API on top of that, whether it's Terraform or like Dave just said earlier, you have the idea that you can have probably a bash script that can take inputs and produce outputs, then that becomes your configuration tool of choice, and that allows you to wrap that API on top. What we don't want to do, though, is go tell everyone to install Corn Shell in order to interact with that script. We rather them now go to a more of a unified API that can then be integrated to the rest of the flow. So we just want to make you look like superstars. Anyone want to add on top of that before I move to the next one? All right, let's run it. So the next one is, and I think I'm going to go to Dave that did the demo on this one. Does this replace CD pipelines in Jenkins or other tools? You're muted.
In Jenkins for a really long time. Having pipelines per repo and things like that were really difficult to manage, right? So part of what makes Massdriver interesting is you can actually define that pipeline and reuse it over and over and over again, right? Terraform apply is exactly the same. You know exactly where the variables are going to be. So now you can just reuse kind of a generic Terraform pipeline. In Massdriver, you can actually stack too. So when we build EKS, you can build with first step with Terraform, a second step with Helm to do your CRDs, right? Maybe
you would do the same thing in Jenkins
with something like Terraform, right?
You
So
have generic
we'll
pipeline or
replace it
something.
in that world. I think CI is different. We've tried really hard to stay out of people's code and out of their Git. So I think your testing and validation practices will look a lot like very much the same. but then you'll push to Massdriver
Yeah.
to actually roll out and initialize these pipelines.
Yeah, one thing I would like people to think about, I always see tools like Massdriver as these like last mile technologies. So what I've seen people do with CD and Jenkins in particular, and it's not actually just Jenkins' fault. When you start building pipelines, think about it. Your pipeline becomes the API. There's something that kicks off the pipeline. It could be like a Docker image or a binary you just built from CI. That thing now causes a chain of events. And what most people are trying to do is create these golden paths where everything just happens, like a bunch of happy paths. The problem is, what happens when two pipelines depend on each other? I need the output of this pipeline to influence this other one. And so what we end up doing? We just have a bunch of variables that you then copy and paste from one pipeline
Yeah,
to another. Even worse.
yeah, but also like
pipeline ain't
SAM
operating no variables
parameters,
'cause it has
like
no
stack
API.
references
So
if
then
your
people just go
service
to the
is in the
cloud
cloud.
console, grab a value, and pop it into the other pipeline and hit run.
You do this only
That's
if you
better
do
than
open
nothing, by the way.
source,
So if you're at that point, no problem.
but you should
But if you think
probably
about a
pay for
better
your
API
state
that calls
management.
change reactions, Massdriver then becomes that new step that collapses this Rube Goldberg machine into something that actually has validation, connectivity, and an actual API.
I think one of the problems here
Anybody wanna
would
jump in?
be
Chris,
like
Corey?
stickiness here, but we'll discuss this
Yeah, I will
after
say
the
one thing
finish.
that we kind of really don't show in the demo is when you define the provisioners, right? So we support Terraform, OpenTofu, Bicep, et cetera, out of the box. When you build your own provisioners, if you are, our provisioners aren't just the IAC tool. You can actually package this is why we call it bundle. You can take your infrastructure as code tooling and your policy tooling and package them together. So I can say, hey, our stack is OpenTofu and OPA. That's what we use. Now, I don't want developers to have to think about that whatsoever. I don't want them to have to copy a bunch of CI/CD pipelines to run the OPA scripts, right? So in Massdriver, you can actually package that in the provisioner. When Dave was kind of showing the configs, you'll see like it says like step Terraform. That runs your entire stack. So when you're dragging that stuff onto the canvas, it's effectively building an ephemeral CI/CD pipeline for your infrastructure. So it'll run things like checkoff to make sure that the plans are good, running things like OPA and infracost, and then it'll do the apply at the end, right? So it's really nice for two reasons. One, again, you're getting all of those compliance and security tools like into developers' hands without them knowing about them. But your maintenance burden as an operations engineer just goes from infinity to one, right? Like if I need to make a change, let's say we're changing out the OPA version, I can change that in the module or the bundle that we publish, and it's going to change for anybody that's using that bundle, right? I don't have to go hunt down 15 different repos and say, hey, who's using Postgres? We're changing the way OPA works with Postgres. I need you to grab these OPA scripts, right? And so, there's a lot that you can do with the platform to kind of extend how it works. And, that's just another thing that we do in the CD space.
All right, I think I got a hard question which comes up a lot when designing APIs, and I think this is really, really important. I think it's Zelen. Why do connection ref types not have version information? Surely they're going to change over time. Who want to take that one, right? Because this problem exists in lots of tools.
No, I can take this one.
Okay.
So for Massdriver, we've had long debates about what major version changes actually mean in operations, and they mean something different in operations than they do in kind of traditional software engineering and APIs that are publicly accessible. So when you think about like Terraform modules, for instance, when you have to make a breaking change to a Terraform module, very rarely does everybody upgrade. In fact, in your organization, a bunch of people use the new stuff, and then a bunch of the other people can't upgrade because there's state surgery they don't want to do and don't have time to do. So now you just have kind of this split in your organization, right? And people are having to go back in time and Git to look at the documentation for the thing that they're running. So for us, with versioning, when you're making a non-backwards compatible change to artifacts, to your interfaces, to your modules, we believe they should be a different thing entirely. So you can either take the change as it is, or you make another version. Now, the thing that's interesting is you open up day 2 operations here. Because it's a separate thing, someone can drag the new version on, deploy it, draw a line from their app to like a new database, test that it works. And now you've done blue-green deployment without having to do all sorts of crazy operations work, right? You've opened up day 2 operations to your developer team. which is pretty awesome.
It sounds like the same thing that the Golang team kind of evangelized quite a bit. Like the difference between a V1 function signature evolving over time. And some people in the Go community, you see a lot of, they just call it either a new function name or they literally put V2 in the name. And everyone struggles with this because it's like, well, I don't want to call it by a new name. I'm doing the same thing. The truth is, if the inputs are different, then the thing is different. And most people never get that far in API evolution, where you need a new thing that is incompatible with the old thing. And when that happens, the signature has to change. So the question is, maybe it's worth ideating on. When I look at that reference, how do I know what I'm referencing?
I'm so concerned about this.
Module name in the reference. So if I do create a new thing, will that new reference point to the new name? So the name itself is the version?
No. So when you publish an update to a module, we make that available to everybody, right? So one of the reasons for this is you can think about like security patching, right? Maybe you need to change your encryption at rest strategy or something like that. You'd want everybody using that module to get that change immediately. Now, we don't roll it out. We let each team take that change. But here's the power of a database with your IAC. If you made that change, you could actually pull the live config for every, let's say, S3 bucket, run it against your change to make sure that every single person in the organization will be able to accept that change without downtime, and then actually roll it out via the API. So you get a lot of power here, pushing updates to people that are using your modules.
All right, so we should probably, there should be a really good follow-up blog post on backwards compatibility.
And yeah, really not sure
evolution.
how it exactly works.
General, because I think Dimitri has a good follow-up here. Is that, you know, in your case, in-place updates that are compatible should be tested if you want to have a drop-in replacement and let people adopt it. But when you want to do something totally different to what VPCs support, it looks like you should create a new VPC module. Maybe you're going to have to name it VPC-V2-thing, so that way people can treat it as a net new thing.
Yeah,
This
I
is
would
horrible.
say if your interface changes, you're likely doing something different, right?
This is bad.
We probably got time
This
for a
is
couple
bad.
more. This one comes from,
Can
there's
imagine
in here.
going to a
So
customer
someone
and
who
saying,
is
hey,
interested,
by the
is
way,
it fair to
this
say
VPC that you have, like, you can no
the
longer
migration
use.
between infrastructure as code tooling?
I can take this one. Potentially, you could potentially use it for migrating between tooling. It would kind of depend on what exactly you were doing. If you had, let's say, deployed something with CloudFormation and then you wanted to
Isn't
move
this a
to,
way of retaining customer but make it
Terraform,
difficult
one
to
of
remove
the
the problem?
issues
Yeah,
that you're going to
exactly.
run into there is that CloudFormation kind of has a record that it created all of those things. You could still import it and start managing it with Terraform, because a lot of these IAC tools have the ability to import. In fact, Terraform OpenTofu added declarative imports and even declarative code generation, which actually starts making it very easy to start taking existing resources, generate the IAC, and then we have a CLI that makes it very easy to then convert that into a bundle. And so I think the bigger question here would actually be, why do you want to change your IAC tooling? Because if the UI presents OpenTofu or Terraform or CloudFormation all the same way, like the primary user experience is kind of agnostic to what the tool is underneath. So unless there's like an edict at your organization that says we need to move everything from CloudFormation to Terraform or vice versa, I would say just use the best tool for the job. If you have some stuff that's in CloudFormation and some stuff that's in Terraform, I would say just keep using it. If it works, if you guys are already maintaining it, just keep using whatever it is that's working. And with a tool like Massdriver that speaks JSON between all of these tools, CloudFormation can talk to Terraform. Terraform can talk to Helm. Helm can talk to Bicep. You don't really need to consolidate around a single tool. You can use whichever tool already exists or is the best to solve whatever problem you're trying to solve.
I haven't seen this many questions in a live stream in a long time. So I'm going to do a time check. Do y'all have time to go extra? We can give the folks bonus time if people have the time. Our minutes on StreamYard aren't going to cut off or anything. All right,
We're good
so
to
we're
go.
going to keep rocking. So it's bonus time. If you have to drop, that's fine. I will hold it against you when I see you at KubeCon. But if you want to stick around, we're going to answer some more questions. We're going to go into some bonus time here. There's another good follow-up, because whenever a new tool shows up, I think this is kind of the number one question: is it all or nothing? So this one is from seeing how Massdriver unifies many tools. Something has to go. Hold on. Let me get back to it. All right. Can developers go provision a piece of infrastructure that is not in Massdriver's catalog and integrate it with the rest of the infrastructure created by Massdriver?
I can take that one too. Absolutely. So if you remember, there was the connection system where you connect a VPC up to a DynamoDB table or up to a Kubernetes cluster, and the application needed connections from Kubernetes and it needed a connection from Dynamo. That whole connection system, it's it's all predicated on JSON and it's all predicated on these typed interfaces, right? That the application said, I need a DynamoDB table type, or the DynamoDB table said, I need a VPC type. And so these types are really just structured JSON. And so we actually have a way that you can build a JSON structure that looks just like what a VPC would produce, or a DynamoDB table would produce, or a Postgres database would produce. And you can publish that and begin using that. To our platform, it kind of looks the same. So you could be managing your pieces of your infrastructure outside of Massdriver. You could have created with ClickOps or something like that, or it could be a separate team and say, I want to leave them managing it. But you can just create, we call it an artifact that represents that infrastructure, and you can still connect to it and use it. And the nice things about these typed interfaces is there's a contract that as long as you provide that information, the downstream module, the downstream IAC that you're trying to connect to is going to work with it, right? It's not like Terraform outputs where you have to have Terraform talking to each other. This is just data that's moving in, and now your module is
Project was
designed to be able
created
to
by
take
people
that
who only
data and
implement
create something
Greenfield.
that you want.
Yeah.
As someone who likes to build little utilities to go with the tools I'm using, it sounds like if I were like to try out Massdriver and I say, you know what, I got some stuff that we don't have any configuration management or automation around.
Folks, if
It
you could
sounds like I could
write
a little script
your thoughts,
that, like,
I would
runs in a
appreciate
cron
it, because
job
right after we
and pulls
finish, like
values
I will
from
kind of
another
like try
system
to
that
summarize
runs
some of
the
my
system.
thoughts that I have
Just
here.
publish an artifact, and that artifact will just stay there, constantly being updated by my little cron job. We're talking like little bash script, cron job, nothing fancy. But as long as I can spit out a JSON block, it's a first-class artifact that can drive a lot of Massdriver system.
Yeah, exactly.
And even with Corey, Corey had mentioned the migration that we're doing. We're helping somebody with a data center migration and swapping between databases. One of the things we do is for their on-prem database, we just publish an artifact that represents that database. It's not managed in the cloud. It's not even managed with IAC. We're just saying, hey, here's the host name, here's the port, here's the password, here's how to get to this database. And then we provision an actual Aurora database. And to swap over now, you just delete one line, draw the other, and redeploy the downstream dependencies. And now everything just swaps over and goes to the new database. So
do y'all know what y'all listening to? Thing is, this stuff ain't supposed to be hard. The problem with all of this tooling is that everything expects you to do everything in one language, one ecosystem, and it has no concept of what happens when things are done out of band. If you've done ops long enough, you know 30% of the stuff we don't talk about is done out of band.
But
Somebody
like I
has
don't
some
think they
emergency
really
thing,
handle this
they
out
have
of
to
band
do
stuff.
it, or you bought some third-party system that doesn't have an API, but it has the information you need, so it gets left out of things. And there's just this blind spot. And even in that mode, it sounds like you can just write some JSON in Vim and pop the JSON as an artifact, and off you go. Will there be drift? Yeah, but drift is better than nothing. Better than a blind spot. At least I can kind of diff the drift, so that's dope. We got a few more questions here. Y'all keep them coming. Here's another one. This is YMO. Can you use Massdriver as a tool to publish a bundle for build your own cloud customer? Meaning, I bundle everything for them, make sure that it's running in their cloud, and it costs me nothing in infrastructure costs.
Approvals.
So I'm a provider. I have a lot of startups that I advise are in this boat. They have like if you pay for it, we'll run it in your stack. In that scenario, can I just like create everything here and then point it at their credentials and have it run in their cloud account?
Yeah, so we didn't really get into this on the canvas, but if, when you're looking at the canvas, you'll see at the top there's actually environments, and so you can just clone an environment by hitting a button, give it a new name. We also have like a preview environment functionality in our CLI that can just clone new environments. We separate the credentials from the environment, so each environment can have its own credential, which is nice. You can have hard isolation between two different AWS accounts. Now, the wild thing is we actually have a number of DevOps consulting agencies that use Massdriver today. They design essentially Terraform modules for all their customers they roll out. And when they get a new customer, they can just throw together a canvas really quick and roll it out to them and say, hey, we just did 30 days of terraforming in a matter of seconds, right? So
Anyone else want to add anything there? I think that's kind of the vision. When we say self-service, not really talking about everybody doing everything themselves. Literally, we're just trying to reduce the amount people have to do. So even in this bring your own compute or bring your own cluster use case, the goal is just to give people a simple API. So if that for you is a bunch of bundles that are already pre-assembled, kind of like a Lego kit, and all they have to do is just say, hey, these are the inputs and outputs. I can imagine if you're managing a bunch of stacks for lots of people, they just become a bunch of environments in Massdriver, and you can just kind of see the big picture. If they ever want to interact with that, the last thing you want them to do is be modifying the low-level source you're using for all your customers. You'd rather just give them a limited set of knobs that they can twist and probably go that route. This is Zelen. You got some really good questions here. I like these kind of day two questions, and I think this falls into the whole best tool for the job. So does Massdriver handle application rollouts, a la Argo rollouts, or is that out of scope and this is just about provisioning infrastructure?
We do also handle the application side of it as well. And one of the real benefits you get with if you're managing your applications in Massdriver is that connection system allows you to pass some of the information that's likely going to turn into environment variables or that sort of config, right? If your application needs an S3 bucket, you need to know what bucket it is, and you also need to associate the proper policies to your IAM. If your application needs a database, you're going to need to know the hostname, username, port, and password. And so really for that infrastructure to be really valuable, there needs to be an application that's depending on it. And so absolutely, Massdriver can deploy applications. It's really going to depend on where you're deploying, right? If you're deploying into ECS or into Lambda, you're likely going to be using something like Terraform. If you're going to be deploying into Kubernetes, you're likely going to be using Helm. What we encourage is to, you're talking about rollouts and application versioning. We just highly recommend everybody use Docker. And that way that the actual versioning of your software and your application itself is already kind of pre-baked into your Docker images and your Docker tags. And that way that you just increment.
You do only Docker because we tell you so.
As you deploy new versions of your application, you create new Docker images, and then you trigger a rollout in Massdriver of your application, and it automatically updates.
So I think for some people, I'm going to.
I think this is L. What he just said is L. It's not W.
The thing about Argo, especially if you have like multiple Kubernetes clusters, there's weird shit people do to roll out software over time, like canary deploys, 2% of customers. It's a highly orchestrated thing. And I think you still need all that config. What is the interrupt for this? So if I were answering this question, I think my answer would probably be like, look, what Argo CD and all those tools do is highly orchestrated that even Kubernetes itself doesn't do. That's why it exists. Is there a world where I say, look, if I'm using Argo rollouts and I still need that information, is there a way for me to like reference that information? Let's say most of my stuff is done in Massdriver, the infrastructure, maybe some of the dependencies that this thing that is going to be highly orchestrated needs. I can imagine that tooling then saying, hey, hold on, let me call the Massdriver API to get my connections and then use that to roll out. So if I'm rolling out a new version across 5 clusters, 5 regions over the course of a week, I still need this information, but I'll grab it when I need it from Massdriver. I mean, Chris, Dave, what are you thinking about that? Because that's the way I would see it. I don't know if this replaces that kind of complex orchestration. I think it's like a different kind of problem set.
Yeah, so this is interesting. I mean, it kind of relates back to Zelen's other question about things like restoring from a DB backup, right? There is tooling that needs configuration that is going to kind of run in the background. So we had a customer recently that was doing a Heroku to AWS migration, and they needed to use something like Picardo to get their Heroku database copied over to an RDS instance in the cloud, right? And so we created a bundle, and that bundle had 3 inputs. It had a Kubernetes cluster to run in. It had, and 2 databases, one from and one to. And you roll it out, and it just went. And we could watch the logs. And once we knew it was caught up, we simply turned it off and cut their DNS over to the AWS, and they had a 0 downtime migration. So you can think about Massdriver as like applying Terraform, but I think that's selling it a little bit short. I think we should be thinking about it as a command center for any automation that you have, and the owner of your configuration, right? Your source of truth about what is happening in your organization now exists in a database that gives you rich write options and rich read options, which is a pretty significant evolution from where we are today with things like GitOps.
Yeah, so I was thinking about this is that there's probably 2 ways to look at it. If you have a complex pipeline in like Argo and one of these orchestration tools, and you want people to interact with it, I can imagine you create a Massdriver bundle with the same inputs or triggers that that thing needs, and then the outputs it produces and abstract it away. I think there's another mode, just to be pragmatic, which is we're all in on Argo. We got it doing some weird stuff that would take a lot to replicate in another tool, but we don't have all the source of truth information that came from the Terraform world. And the last thing I want to do is in my Argo rollouts is be calling Terraform, or worst case, working with a whole state file. That's insane. And instead, I don't know if people are using Helm charts or Terraform or some other thing, CloudFormation. I'd rather just turn to the Massdriver API and say, this is the data that I need to complete this rollout. So I can kind of see it as using it in 2 different ways. If you're all in on Massdriver, abstract away the rollout tools. If you're in the best tool for the job, you can connect them through the API and let Jason do the thing in between. I think that's just probably like the most pragmatic way that a toolsmith is going to operate with this. We're going to go with 2 more real quick. There's an interesting question that came out, which is, you know, how does this kind of like relate to Backstage? The thing that I think made Backstage kind of at least get some buzz,
Yeah,
get some attention, is because
I don't have a
API
lot of
support.
experience
If
with
you have a bunch of
Kubernetes, so a
microservices
lot
in a
of this
company,
stuff,
you have
like,
no
I
idea
cannot
what all those
provide an
microservices
opinion
are.
on,
You have
like,
no idea who
Backstage,
owns all
Argo,
these
whatever.
microservices or what they
Helm.
output and things like client stuff. How does Massdriver relate to Backstage, and is there any integration opportunity between Backstage and Massdriver?
Yeah, so Backstage is an awesome phone book. Like when you have an organization as big as something like Spotify, you don't know everybody's name. You don't know everybody's team. You don't know what applications they're running. It's really important for you to kind of have this directory, right? I was really excited about it, and I tried to manage infrastructure with it. And I found that I was really constrained because I could make a DynamoDB table, but when I made my application, I couldn't reference back to that DynamoDB table. It felt like just ad hoc running Terraform. So for us, we felt like there was a different interface for actually managing this infrastructure and making it feel good for developers. Now, in terms of integration, because we have that API, again, because we have a database at the heart of our operations now, we can pull in information into our read tool like Backstage way easier. We can know the configuration and the resources and their scale of every service. That is really, really difficult in GitOps today.
Kevin had a question around approvals. And I think, Corey, you talk about this kind of policy stuff quite a bit. So what about approvals? Can different teams approve different stages through the deployment? Right, so how does this permissioning system work? Do people just log in, see the whole catalog, and just start doing whatever they want? Or is there a way to kind of limit things or approve what can be connected and what can be deployed?
Yeah, so as far as approvals go, like our philosophy is you own a project, and that project can have as many environments as you want, right? Like you should, right? You build it, you run it. I own dev, I own staging, I own prod, right? And so the idea with Massdriver is like getting to this pre-approved infrastructure. We're not giving you guardrails. Like guardrails is the term everybody uses a lot. When you think about a guardrail is too late. Just like when you're driving a car, man, if I crash into a guardrail, I've wrecked my car. I'm probably getting a ticket, right? And so we like to think of our approval system as more of like lane assist, like to stop you from getting into a bad place in the first place, right? So if we can put things in place like marking a field as immutable once it's set, right? That context-aware API. I don't want you to change the region. I want you to have full control of a Dynamo table, but you can't change the region once set because it will destroy your data, right? Or I want you to be able to upgrade and do a little day two operations yourself as a developer, right? That's true self-service. If self-service stops at day one, it's more work for operations. So how can we push that forward? Well, I'm going to let you deploy Postgres. I'm even going to let you upgrade Postgres, minor versions at a time. It's Simver aware, right? So, what we want to see is really
Nope.
empowering developers through self-service and
Yeah.
starting
It's
to
like
codify
you do
a
whatever
lot
you
of
want to do.
our operational
That's
expertise
what
and
he's
the
saying.
non-negotiables of the business into the modules. So they can go. They're approved by default, not approved reactively, in a PR sometime down the line.
This next question is around like troubleshooting and debugging.
We'll
Right?
talk
It
about
seems
this
how
later. I think this
Massdriver
is a massive help.
unifies many tools. Something has to go wrong at some point. What is Massdriver's approach to handling such situations?
Do you mean like from like the end user point of view, like that, like Massdriver's having an issue, or like
Yeah, I would say think about it. Like if I got this thing that was built off of a Helm thing, that bundle, and I drag it out there, and then that seems to work, and then I got this other thing that's like a Helm chart that's pulling.
Yeah, by the way, like Terraform state.
Yeah.
So at this point, now the underlying infrastructure or execution engines are maybe at fault. Like, how do I even begin troubleshooting that?
Yeah, so the provisioners, so like we mentioned earlier with our provisioners, so we have a handful of them that are pre-built. All that logging shows up in the UI, so you can actually see the errors going through there. And if you build your own provisioners, you can put whatever information you want to put essentially in the Massdriver logs. So when you hit deploy, that panel will slide out. And then we save those for all time. So you have snapshots, you can go back and like troubleshoot. So if somebody deployed something yesterday and it went wrong, you can see the logs. But B, we have that visual diffing tool. So I can say, okay, well, what did they change, right? Like what happened, right? And so in the platform, we also have this notion of alerting.
Just diff, baby. Just diff inputs, baby.
In a demo, but again, trying to push self-service so developers really do feel empowered to manage things themselves. The platform has this alerting system, and you can either put your alerts and your metrics in your modules, or a developer can come in the UI and say, hey, this is important to me, or this alert would be important to me, so I want to add it, right? So they can have this like additive approach. And it's really nice because from the developer point of view, when something goes wrong, Massdriver will send you an alert. And like today, what happens when you get an alert through PagerDuty, right? So you get an alert, it links you to a Datadog dashboard. You're looking at a Datadog dashboard. You're trying to figure out what's going on. You figured out what's going on. Now you're looking for a repo. In Massdriver, we'll send you the alert. You click on it. We take you to that piece of infrastructure that failed the rollout.
Alerts.
Highlight it, and you can
alerts
see
when your infrastructure fails.
Diagram. You understand the context of your infrastructure.
You get a direct link, guys.
One click, and you're looking at the metrics panel right alongside that database. And I can see something like, and I'm sure people have had this happen before. Maybe I have a very stable application. I haven't deployed it in weeks, but all of a sudden it went down. Nobody's changed anything. Nothing's changed about the request profile. Nothing's changed about the traffic. What happened? Somebody made a change to the data. The CFO said our cloud costs are too high. They made a change to the instance type, which affected our connection pooling, right? That is hard to figure out in the world that you're in today. You get this alert, application's down, can't connect to the database. You're looking at Datadog, and you see, hey, it can't connect to the database. I don't know why, right? That management of the application and the database is usually in two separate Git repos, right? Two separate PR histories, and it's all in one place. It makes it much easier to lower that mean time to resolution because you're looking at the context and all the metrics for your entire dependency tree in one place. And then from the operator point of view, what's nice is, let's say that you have a developer that this self-service on kind of the day two and management of this themselves, but they get to a point where they do need your expertise. So they're reaching out to the person that wrote the module and they say, hey, I'm having an issue with this. Mm-hmm. You might not know this team. You might not have seen this project, but in Massdriver, you come in and you see the instant picture of their entire infrastructure, their entire change history, and you can get up to context in a matter of minutes versus looking at a Git repo and trying to figure out like, okay, they got 1,000 lines of Terraform. Like what all are they using? How's it all connected? You have it in the picture. So I think it lowers the mean time to resolution significantly for the developer, but it also makes it much easier as you as the operations person when you finally get shoulder taps coming in at 2 a.m. to get the relevant information quickly to be able to resolve the issue.
We're going to probably do literally two more. This one's probably a big one. Because there's a lot of imperative things that seem to happen. Like, I have a stack that's working right now. All we did in the beginning was expose like port 180. Now we want to expose port 443. And the app is already bound to that port. And sometimes you just got to go in and just kick the
I just
firewall.
don't
Like,
understand
hey,
the value.
I want to now enable 443 as well. So that'd be like an imperative
$50
action.
per
In GitOps,
receipt.
sometimes that's as simple as just updating the config with that expose, hit save, and then the pipeline
Keep
kicks
it
off.
coming, guys. So
How do
we
people
do
think
proper
about
summary with your help.
these imperative actions like redeploy the app, same version, I just rebuilt it, so there's not a lot of data triggers you can use. How do you think about these imperative actions? So I think the big question here is that, I think this is from Kevin, how does that apply to things like firewall rules doing deployment? I need a service deployment in AWS to talk to a service on-prem, but there needs to be a firewall rule added. How would you go ahead and think about that?
Good.
For this specific question and kind of example that he gives, I'd be curious which firewall rule he's referring to. If it's the AWS firewall
I'm
rule,
gonna make
or
it
it's the-
hard. My Cisco thing on-prem, where we just run in, log in, and run some Cisco commands to open up the firewall.
Yeah, like
How are we
fixing
using
your
that
on-prem
in Massdriver?
when
It
you're
sounds
doing
I would
like
go create my own
terraform or
provision,
whatever, it's hard.
make an interface for that thing, and let it do its job to say, hey, there's another thing that I would like added. But what happens when you don't have that? Like, how do you kind of deal with these two things?
Yeah, I think as much as possible,
I think
attempting
this
to
is
use
difficult
IAC
problem,
to do things.
to be
AWS,
honest.
you can use IAC to manage
You're
all of
fucked
your
either
firewall
way.
rules and things like that. You are going to run into perhaps situations like this. Maybe you can start managing Cisco with some type of IAC, and you could try to bundleize it that way. I would say if you're already in a situation where the way that you're managing all of your firewalls ports on your Cisco appliance is just via going in and clicking and changing settings and things like that, then that's probably the process that you're going to continue wanting to run. However, you can still use, like we've talked about, using custom provisioner. So if what you're trying to do goes outside of the realm of the provisioners we support, the Terraform with Tofu, Bicep, Confirmation, things like that, you can have your own provisioner that could just be running a shell script. It could just be running I'm not as familiar with Cisco routers, but maybe there's a way that you can actually like execute Cisco within a container, some configuration things to do it that way if you choose to. But it would really depend on kind of what your current practices are around managing, those sort of on-premise routers.
Yeah, and
go ahead,
seeing that follow-up real quick, Kelsey, the Palo Alto rules in the network, right? You could imagine a step in your provisioning that actually opens a ticket when you deploy something. So it's like, I got an app ready for connection now. Open up a ticket, and because I have that artifact information, I can say, here it is. Let me know when it's done.
You could also open a ticket in any CI/CD, right?
It was that extensibility. It sounds like Massdriver has a lot of that extensibility. A lot of what you see is what you get driven tools don't have extensibility. There's no way to put a custom executor. There's no concept of an artifact that allows you to bind things, even things that the platform didn't create. I think that's the thing that probably answers like 40% of these questions around what if this doesn't exist? What do I do? It sounds like, look, if you can get to the point where you can execute something inside of Massdriver or even outside of Massdriver and publish an artifact, that's your workaround until you can do the native things you have. And honestly, that's just like a lot of Kubernetes ecosystem. If you think about it, Kubernetes, that whole operator pattern, if you don't have an operator, what do? You just got to put that data somewhere else. It could be a config map, it could be in Vault, it can be in some other bucket, but then that information is only within inside of Kube, and then you have to think about exposing it via another API and give it semantic meaning. I'm going to wrap it up here.
Yeah.
A ton of questions.
Yes, please, let's wrap up. I'm tired.
I think what the team's probably going to do now is like, this is the type of feedback that products like this need, these type of tough questions about day 1, day 2, what we do in these scenarios, and maybe there's going to be a follow-up blog post where we get into the nitty-gritty. There's also some examples, like you want to go through this demo and touch the code, touch the product yourself with your own hands. I totally think you can do that. The team's going to post the GitHub repository where you can run through the same demo that Dave
Yeah, let's take it.
I think if you're an engineer or practitioner like me, you want to touch it. That's your chance to go touch it. So the link gets dropped in the chat. We'll put it in LinkedIn. We'll put it on YouTube. I'm going to summarize a few things here. There's nothing wrong with infrastructure as code. It's just not enough. getting the entire company to learn Terraform and Helm and Kubernetes manifest and those one-off bash scripts, it is not sustainable. It doesn't work. We've been trying for 20 years. I don't care if you call it DevOps or platform engineering. It's the same thing. Ain't nobody trying to learn all of that. The key is to take your things that you are doing. I don't care if you're using the cloud provider native technologies like CloudFormation or whatever, or you like Kubernetes manifest and using cross-plane for everything, or Helm charts, just doesn't matter. The goal is to make it usable. So when we said self-service back then, that's what we meant. We meant giving people an abstraction away from all the nuance of that tooling. And some of you all asked some really good day two questions. What happens when the abstraction leaks? It inevitably does. That's why you want logs next to the configuration tooling. So
You
when
not
your
only
stuff
want
fails,
logs,
you can see
you
why.
want
and then be
have a
proactive
way to
about it
actually
and do
fix it.
something about it. And now we got to think of going forward is, I think if you've done GitOps and if you're doing it right now, you didn't do anything wrong. I think you really thought through this idea that there has to be a process and workflow, but I think you're missing validation and ways of having the workflow work for itself. And the biggest standout today for me was when Dave dragged out DynamoDB and it created the VPC based on its needs of that particular resource. This is what happens when you add a type system and an API with validation and constraints to those individual modules. We're just scratching the surface here with what we can do going forward. So I'm not going to make any promises on this call, but I do promise you one thing, that if you go try it and you have some feedback, the engineering team is right here. Right? The same people that are showing it to you are the same people that are building it, and they're super accessible. So go find them. You can even tag me. I'll answer as many questions as we can. I want to give a big shout out for everyone hanging out with us.
Is
almost
Kelsey
a full
working
hour and
for
a half.
them?
So I'm pretty sure you got jobs to do. Go do some of that, but go put your hands on it to see if we're telling the truth. Is this moving the needle for infrastructure as code?
Yeah, like, but I don't know if he's related to the project or not. Like, that's a question. Okay. Anyway, let's do wrap up because I'm also tired. We can close this one. I want to check. Someone mentioned their Dagger. I want to check this. The repo. We can also do at some point. Like, let's do our Excalibur and let's see what we get. All right. So some of my notes. So here is what I liked. So imagine you build Terraform modules, right? And maybe you did a good job of that. Like orchestrating Terraform modules and like stitching them together, like there are problems there, right? Like a typical example of, I mean, it's not like unsolvable, but it's also not pretty, at least in Terraform world, right? So you have your VPC, right? You created, maybe you used like some VPC module, maybe you wrote your own, and then like, okay, you do EC2 or RDS, right? You do EC2 instance, you do RDS, right? So you need, like, for sure you need subnet IDs, right? So there is this dependencies there. That said, it's not the same stack, right? Because like within the same module, like all these dependencies like super straightforward, but between stacks, between modules is like where some of these problems begin, right? So let's kind of like just go through it, regardless if Massdriver exists or it doesn't, right? So subnet ID. So like you need to somehow pass around this subnet ID. So like the naive approach is you do, like you copy paste it, right? So like you have it, here is an output. Right? And then like you put it as an input as a string, like approach number 1. Approach number 2 is you store it in some, like you put it somewhere in the state. Like, okay, so naive approach, copy paste strings. Second approach is store values somewhere. This would be like parameter store, right? SSM parameter store. This is like how you would often stitch CDK stacks together. Approach number 3, you would use your IAC cloud offering, right? So in this approach, you use HashiCorp, like HTTP Terraform or whatever the name of the day is, state, or you would use like Pulumi cloud state, and then you do like you can reference these values, right? So it's like I think data remote state or something like this. Pulumi is the same way, it's stack reference, right? Now I must say there is this part of it that like it's a string, right? So like I agree, like it's a string that like technically like can be something else. So my like kind of like first point, like it's glorified JSON schema for inputs outputs between Terraform modules, Helm, Bicep. So it's kind of like this stitching together. Let's say like I cannot speak a lot for Helm, right? I think like there are its own set of problems with Kubernetes. Like I don't have enough hands-on experience there to kind of like understand, is there actually a need to stitch Helm and Terraform module together? Because I like, to be honest, I'm not sure there is. Right? But you guys tell me if you use a lot both, right? But anyway, let's just focus maybe on Terraform modules because that speaks to me, right? So like it's about these connections between modules. So what I really liked, I think catalog of modules is great idea. Like I haven't seen it anywhere yet. Like kind of like this self-serve, like I would say the closest alternative to this is a AWS Service Catalog, by the way. Right? So like, and actually there is something that AWS Service Catalog will do better here, because you can be very, very granular of who can see what. So you can say, IAM group, whatever, can see products XYZ, right? And like, and they don't have this. They kind of like told it like, you almost have like all or nothing. Like you have your own environment, but like then you do whatever you want to do there. So like in terms of permissions, Service Catalog, I would say here is pretty good. Like that said, I would say still like cataloging Terraform modules, like it's still pretty good idea. Like going somewhere, seeing your internal catalog of the stuff you build. Like, do you guys know any alternative to this? Because like I personally don't. So I think this is good, right? So like you build your module, publish it, others can see it in your org. It's kind of like pretty cool. I think visual inputs are also pretty nice, right? Because otherwise what you do, you take a module, and then like you go to some doc page to like readme, and you hope that that readme has proper. I mean, variables TF is kind of that, but it's kind of like not that as well. Like having it visually does help a little bit, right? So that said, do they support complex objects? Right? So like stuff like I'm doing where you have a list of dictionary of like maps of objects with like different parameters. I'm not sure they do. It seems like their parameters are like, okay, list of values, integer string, like checkbox, like something simple like boolean, right? So because like if they don't support complex objects, then like you cannot use their product at all, I think. So inputs presets. So I think like I would say these two are the most powerful here. Like there is something about visual part that like especially this catalog of stuff and like understanding how to structure inputs is awesome. Then the next things are it's kind of like okay, it's like whatever. I like input presets I would say are still useful, but like I wouldn't call a big selling point. You cannot really do presets in Terraform that well. Like you just have your defaults for the module and you either like use them or don't. Like you cannot say I have a flavor X or I have a flavor Y. You can kind of do it if you provide it as its own like variable or something, but it's like it's probably not worth doing. I like this part where you kind of have a preset and then like you override whatever you want to override, right? I think it's okay. Now, this is Terraform only problem. If you're using Pulumi here, there is no problem whatsoever, right? So we would like, let's look at this. So for example, I have here my own VPC module, right? What I can do is I can subclass my VPC module with like different flavors. Like I can create an enum of like flavor 1, flavor 2, like something like this, like wrap it in its own class, or like wrap, like create a like a fun, like it doesn't matter if it's another function or class, like it's very easy to do, like create these flavors of configuration, I would say. So this is, I would say, is okay. It's like, but like I wouldn't use their product because of this. Policies. So paid Terraform, Pulumi has its own policy stuff. You would even be able to do it in Pulumi. Again, because it's code, right after you finish running it, you can do some kind of like checks in your code. Like, you know, if you need policies, just use paid Terraform or just like, let's, actually, that's something I do want to check. Pulumi policy. Yeah, you'll have to like check this at some point. Like I don't know how good this works or not. Then of course you for policies you also have AWS config as well, right? So like your cloud provider stuff, which I think is pretty good, right? So like inside of your account, which is essentially a source of truth, you can like find the problems. You can block people from doing stuff with SCP policies. So like meh, like you need this, like you can do it other way. Their counterpoint was like we can not only manage Terraform, but like they only manage really Terraform and Helm. So like, do you really need this policy stuff for Terraform and Helm at the same time? Like, I don't think so. Diff of your inputs. That was like whatever. Like really? Like they show like 2 inputs. It's like any GitHub stuff is like will do it 200% better, I think, right? Just diff commits or like diff files, not that big of a deal. So I'd say at this point we can kind of like move higher. So this one, I think I need your help. Like, I think there is something useful here, right? So like if I say that the input for my EC2 or RDS module is of type subnet, so like I can kind of like do type safety check here. I think, but I'm also not 100% sure it's that needed. So like it was useful. Like I can see this visual workflow being useful. So imagine you kind of like you create multiple VPCs. Like I don't think what they showed where you start from RDS and they automatically create VPC for you. I don't think this is like awesome. But what I think is awesome, let's say you build number of VPCs, right? You have something like this, and then you can kind of see them as in a catalog. Let's see. Why it doesn't allow me to type VPC1, VPC2. And then like you also have some metadata, right? So like you have it somewhere, and then like dragging and dropping this, like there is something that feels nice about it, right? So like you would drag and drop your RDS, and then here you drag a line saying that this subnet ID one will be used in RDS. Like there is definitely something nice with it. So, okay, awesome. I think there is something useful here. Now, in other infrastructures code tool here, like including Pulumi, I think like the maximum I think that you can do is you can validate here in the module that the provided subnet ID is of correct like format, right? Because AWS resources have a proper prefix. So you can say, okay, it starts with subnet minus, so it's good, right? So you didn't give it like something else. At the same time, it's like if you give it something else, like the Terraform will yell at you immediately of like invalid, like because cloud provider API will not allow you to use VPC ID instead of subnet ID, right? So like still I think there is like some value in like having it visually. Right, so then like policies is whatever, diff of inputs is whatever. Now I think this is big one that like this is where it's pushing me towards like I'm not sure like I can use this. All of your inputs are right now, they're no longer in Git, right? They will be in my Massdriver. So all of your infrastructure is now in managed service, to which like you have, there is not much you can do with it. Like I don't know if they allow you to at least download it as like some kind of file, just so make sure that you have it so you can back it up, and then like in the worst case scenario you can like write your own like parser and like extract the state. But if not, you're in massive trouble. Like let's say like they're hacked or something, that is deleted, you don't have a backup for it, right? Like local, yikes. Like ISDev, thank you so much for following. This is the same problem you have with Terraform state files. I don't think so, because like you can look them up in the vault, right? You can make backups, like it's just a JSON file that you can download. So like I haven't seen that they expose this state. Like at least maybe if they do, then I guess it's okay. That said, because it's like, you know, their own product, you are still dependent on their business, right? So what happens if you don't like them anymore? What happens if they increase price that you don't like, right? Like, what do you do next with this? Like with Terraform, there is something you can do, right? Like you can say, okay, like I don't like HashiCorp Vault. I will not pay for the cloud product anymore. Like I will just run everything locally. Like you can do this. With Pulumi, Pulumi is currently the engine is open source, so you can say like, okay, like Pulumi pricing is too much. I will self-host this. Like it is open source. I can do it. This is not open source, right? Let's check. Is this open source? Like, can you self-host my Massdriver? Massdriver GitHub. This is CLI. No. Docs. Yeah, so they are not open source. So, like, there is like anything that you don't like, I think you are in bad shape here. Let's start with the fact HashiCorp has changed license because such companies their core is Terraform. Yeah, like I'm not defending them. Like I think that was a bad move. Like I'm not a HashiCorp shield, so I think what they did with the license was bad. That said, you're not in the same position as you would be in Massdriver, right? If you like don't want to use their cloud product, because Terraform you can still run locally, and now we also have OpenTofu, so like you can take that state file, download it from their cloud, and like do something with it. Here, I'm not even sure you can download the file, but even if you did, like you cannot self-host the tool somehow to like keep working with this. Like you have to like completely like deconstruct it. So I think this is a major yikes. Like you kind of like you lose your inputs, you lose your state, like you have no control over it. I think this is to me is concerning. Now another stuff that they mentioned, like I was like Elmao, like I can't. So they were like, okay, what if your module version changes? So you increase the module version and they say, you have to create a new deployment of that module. It's like, I don't think you guys understand how it's working. It's like, if you create a new version of the module, like, and maybe it's like foundational module of VPC, like very likely you will not touch it, but sometimes you do, and like I don't create a new VPC, right? Like I need to update the existing one, and it's a choice that I have to make. Like you cannot make it for me. Like I don't think this is a good answer here. So then the last part that was also yikes was this approvals or authorization. Like this is also like kind of wild to me because they are like, okay, we have this visual workflow. And the question was, okay, like I want my security team to kind of like come in and like approve it. They're like, no, like we like if you have a like you can deploy whatever you want in this environment. It's like, really? Like I want this team to be able to approve deployment of this infrastructure. I want go-to networking team and for them to check if like if I can't do this, right? So like this was very weird to me. But I guess, you know, like they had to navigate a difficult question, I think. Yeah, so overall, I think it's worth trying the tool. Their pricing is on per seat, so like every user that needs to deploy infrastructure would need to buy a license. Oh, you can only do 2 accounts per seat. 2 projects and 2 accounts. Okay. Like I don't know, seems arbitrary to me. And then like if you are not doing this, then it's custom. Then it's like we'll give you a bill. Like I don't know. I think it's like worth trying. Like maybe I will change my mind if I play with it, but like so far I'm not convinced, though some ideas are good. Now something else that definitely like kind of like popped in my mind was system init. And system initiative is something that I tried on my own and will probably try it again on the stream. That is also about visual workflows. I think they have system initiative have really good ideas, but like there are a bunch of problems that I'm not sure they can solve. So that's for another time. But I think their idea about visual workflows, I think, is even more interesting than this guy's. So yeah, what do you guys think? Let me know, because I don't know. Worth trying, I think. Worth seeing it for yourself. Maybe like some of these points that I didn't get correct from what I heard. Yeah. Not fully convinced, but I also cannot say that like this product shouldn't exist. I think there is something that like the Terraform ecosystem like just not giving you. So we'll explore it sometime on the stream. Right, with that, guys, it has been a while. It has been 4 hours. I think I will stream tomorrow, maybe around the same time. Check my schedule. Subscribe to me on Twitch, YouTube, and on Discord. You'll get notifications whenever I go live. So make sure you do that. Thank you so much for sticking with me, and until tomorrow. Bye-bye.